and thanks to everyone for joining us today to discuss a topic with enormous implications for the future of our planet. We're here to consider methane leaks from the oil and gas sector. Specifically, we're going to talk about the science of methane leaks and how that science can be applied to characterize oil and gas methane emissions on a large scale and inform mitigation efforts. The importance of doing so cannot be overstated. Methane is a powerful greenhouse gas. Reducing atmospheric methane levels is an important way to slow the rate of climate change in the short term, but buy ourselves more time to implement long-term climate policy. There's broad agreement among scientists that reducing methane emissions from oil and gas operations is the simplest, most cost-effective, and most technically feasible methane emissions reduction option at this time. Oil and gas sector emissions are the low-hanging fruit of methane mitigation. We can take action today to solve the problem. Unfortunately, the oil and gas sector has a long way to go to rein in methane leaks. An investigation conducted by the Democratic staff of the committee has concluded that oil and gas companies are not taking the actions that are needed to achieve large-scale reductions. The staff investigation found that the companies are failing to address super-emitting methane leaks, neglecting the use of methane quantification data, and deploying innovative methane detection technologies too slowly and too inconsistently. In America, if America is to reach the methane reduction targets and live up to the climate promises, such as global methane pledge, oil and gas sector methane mitigation must be informed by science. The oil and gas sector must do a better job of adopting science-based approaches to solve the methane leak problem. Science lies at the heart of everything this committee does, and today will be no exception. Our witness panel features some of the country's leading experts on methane emissions from oil and gas sector, and I'm grateful for their participation. They can help us understand the threat posed by methane leaks and how to effectively confront them, where our knowledge gaps are, and the potential for innovative technologies to be part of the solution. We must also consider how the government scientific enterprise, the federal scientific enterprise, can play a more active role in improving our understanding and strengthening our capabilities for dealing with methane leaks. Research programs across the federal government have potential to engage constructively with industry and with the scientific community. Together, we can advance knowledge and develop tools for oil and gas sector methane emissions. Today, we will explore where federal research investments are most needed. There are many dimensions to the issue of oil and gas sector methane leaks. If we listen to science, and if we allow ourselves to be guided by it, we will equip ourselves with everything we need to make informed decisions. I look forward to a vigorous discussion. And now I yield to Ranking Member Lucas.
Thank you, Chairwoman Johnson. And we're here today to discuss methane emissions and how to measure and address them. This is a complex problem, largely due to technological limitations and regulatory barriers. Compared to our ability to quantify carbon dioxide emissions, we lack knowledge and tools to measure methane in an accurate, timely, and cost-effective way. That in turn makes it hard to address sources of emissions. But that's starting to change, and we're beginning to recognize methane as what I would call a low-hanging fruit. It's a short-lived climate pollutant, so as we work to remove the emissions of carbon from critical industries, the ability to identify and plug methane leaks is a quick and effective way to slow the rising global temperature. The good news is that our energy industry has already made significant progress to reduce emissions in oil and gas operations. To give you an idea of their success to this date, methane emissions in the United States have decreased by 17% since 1990. That's all the more impressive given that during the same time period, U.S. natural gas marketed production has increased by 99%. We're producing more energy with fewer emissions. Much like our reductions in carbon dioxide, innovation has and will continue to be the better driver of action than regulations or prohibitions. Simply put, we don't need to tax or ban methane in any way. We simply need to cut red tape and allow the energy, agricultural, and waste industries to use the breakthrough technologies being developed and refined every day. And that leads us to a major roadblock when it comes to methane research and development: regulatory burdens. For far too long, EPA regulations have stood squarely in the way of technology deployment. As it stands right now, any operator that wants to use a technology other than a handheld optical gas imaging sensor must complete and submit an application for an alternative means of emission limitation. But a massive problem arises when you ask how many AMEL applications have been approved for methane monitoring technologies. The answer is zero, none. In fact, it's such a tedious process, only one application has ever been submitted. And if you are lucky enough to be the first to use this coveted approval, it doesn't make your future prospects any easier. If granted approval to use a new methane monitoring in the Permian Basin, an operator would have to reapply and go through the entire process again to use the same technology at a different site, even if it may just be down the road. This, my friends, is the very definition of bureaucratic ignorance. Energy prices are at record highs. Now's not the time for more virtue signaling regulations. We need to support cleaner American energy by empowering industry and encouraging innovative technologies. And yet, President Biden and the EPA recently proposed a new methane rule that creates additional unnecessary government mandates and fails to streamline the process for private companies to deploy innovative technologies. This is heavy-handed. Regulatory approach will be even more of a burden on domestic producers. And all the while, these policies are doing nothing to alleviate sky-high energy prices, even as the price of natural gas is projected to increase by 30% for the average household this winter. Despite my frustration with the administration's failure to address energy prices and flawed approach to emission reductions, there's still reason to be optimistic. One of them is with us today, Dr. Greg Rieker and LongPath Technologies. While working at NIST, Dr. Rieker completed the proof of concept research that takes Nobel Prize winning laser technology and applies it to a long-term scalable emissions control. LongPath has since gone on to receive 2 different ARPA-E awards from the Department of Energy. LongPath's work has been blind tested, verified, and commercialized. It's a very real success story of utilizing the proper channels of federal resources and then letting the market determine the fate. I look forward to hearing from Dr. Rieker about LongPath's story, technology applications, and how we can better enable more successes like this in the future. But before I close, I'd like to note, and I always offer my notes in a very respectful fashion, that for the record, the staff report under discussion today, I should say, wasn't made available to the minority until 24 hours ago. Now, I understand the majority controls the proceedings here, and they have the prerogative to conduct business as they wish. But on issues of this importance, I'm disappointed to see that we're not acting in the collegial spirit that Chairwoman Johnson and I have worked so hard to establish. I suggest to everyone that if we want to make a difference and address important issues like the one before us, this isn't the right way to go about it. With that, I yield back, Madam Chair.
I am submitting testimony for the record, and I'm attaching the Democratic staff report to the opening statement. If there are other witnesses or, if there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. And at this time, I would like to introduce our witnesses. Our first witness is Dr. David Lyon. Dr. Lyon is a senior scientist for the Environmental Defense Fund. Dr. Lyon's work focuses on the analysis of methane emissions data, as well as research into technologies and policies to reduce natural gas leakage and minimize the climate impacts of natural gas development. Prior to working at EDF, Dr. Lyon worked for the Arkansas Department of Environmental Quality as coordinator of the state's air pollution emissions inventory program. Following Dr. Lyon is Mr. Riley Duren. Mr. Duren is Chief Executive Officer for Carbon Mapper, a research scientist at the University of Arizona. Carbon Mapper's mission is to use satellites to provide global monitoring of methane and CO2 emissions at the facility scale to help accelerate climate mitigation actions. Prior to co-founding Carbon Mapper, Dr. Duren served as principal investigator for 10 research projects involving greenhouse gas observing systems and data analysis frameworks, and his work supporting programs at NASA, NIST, and NOAA. Our third witness is Dr. Brian Anderson. Dr. Anderson is the director of the National Energy Technology Laboratory, NETL, within the Department of Energy. He manages the NETL complex, leads NETL's national programs in carbon-based energy, and provides program support to other DOE offices. Under his leadership, NETL initiated critical technology development and deployment projects aimed at decarbonization, reduction of greenhouse gas emissions, and low carbon power systems. In 2021, the Biden administration named Dr. Anderson executive director of the Interagency Working Group on Coal and Power Plant Communities and Economic Revitalization. Our final witness is Dr. Greg Rieker. Dr. Rieker is the co-founder and CTO of LongPath Technologies and associate professor of mechanical engineering at the University of Colorado. Over the past decade, he led a team to transition Nobel Prize-winning laboratory laser technology into automated regional scale methane leak detection systems. LongPath Technologies was founded to commercialize that system into a broadly scalable, continuous monitoring system for oil and gas infrastructure. For this work, Dr. Rieker was recognized with the Colorado Governor's Award for High Impact Research. As our witnesses should know, you will have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. Lyon.
Thank you. Madam Chair, Ranking Member Lucas, I am David Lyon, Senior Scientist at Environmental Defense Fund. I've spent the last decade researching oil and gas methane emissions, working closely with experts in industry, academia, government, and other environmental organizations. Environmental Defense Fund is a nonprofit, nonpartisan organization with over 3 million members and 750 staff that uses science and economics to find solutions to the world's most serious environmental challenges, including climate change. Methane is both the primary constituent of natural gas and a powerful greenhouse gas with over 80 times the warming potential of carbon dioxide over the 20 years following its release, responsible for 1/4 of today's global warming. The good news is that global temperatures in 2050 could be reduced by 0.5 degree Fahrenheit if methane emissions are cut in half by 2030. The oil and gas industry is the largest industrial source of methane emissions, but also has the most cost-effective solutions for reducing emissions, since capturing methane often means, apologies for not having the video. Yeah, so the good news, capturing methane often allows companies to sell more natural gas. Additionally, the methane mitigation industry provides many high-paying jobs and is rapidly growing. However, delaying the widespread adoption of mitigation measures will substantially worsen climate impacts and cause continuing harm to communities and workers. Although mitigating methane emissions is usually cost-effective, there are several challenges in detecting and quantifying emissions in the oil and gas industry. First, oil and gas infrastructure is widespread with diverse site types, including wells, tank batteries, compressor stations, processing plants, and pipelines. Second, peer-reviewed research has found that the top 5 to 10% highest emitting sources typically account for over half of oil and gas methane emissions. These sources, sometimes called super emitters, can occur at almost any site, and their locations are difficult to predict, so all sites must be inspected for leakage. Finally, there are many emission sources, particularly super emitters, that emit intermittently. Therefore, leak inspection surveys may miss these episodic emissions if they are only observed during their off state. Due to these challenges, the US EPA's greenhouse gas inventory has been shown to underestimate oil and gas methane emissions by 50% compared to a measurement-based study that estimated 13 million metric tons of methane, equivalent to 2.3% of the country's natural gas production and representing the waste of over $5 billion of a valuable natural resource. There are numerous available and emerging technologies for detecting and quantifying emissions, which can be grouped into two general categories: wide area screening and continuous monitors. Screening approaches typically use remote sensing technologies deployed on aircraft, drones, vehicles, or satellites to quickly inspect large numbers of sites for methane emissions. Many of these approaches both quantify emission rates and generate an image of the methane emissions plume, which can help operators determine the exact cause and source of the leak. In contrast, continuous monitors are installed at a stationary location to detect and sometimes quantify emissions at one or more nearby sites, continuously or at a high frequency. For both screening and continuous approaches, rigorous field testing plus a clear understanding of how the technologies are incorporated into operator work practices is critical for their successful implementation. Federal agencies can effectively support research and implementation of methane detection, measurement, and mitigation technologies by funding two types of programs. First, accelerating the research and development of technologies, including instruments and data analysis. And two, collecting methane measurement data to better characterize emissions. Previous federal research and development efforts, such as the DOE ARPA-E Monitor program, have been highly successful and facilitated major improvements in several technologies. Additional funding could increase the diversity of available approaches and drive improvements in performance while reducing cost. Agencies such as NOAA, NASA, and NIST could use multiple measurement approaches, such as satellite remote sensing, to annually quantify both total and super emitter methane emissions in major US basins, which EPA could then use to assess the accuracy of their greenhouse gas inventory and prioritize updates. Additionally, emissions data could be used by EPA to increase the efficacy and cost effectiveness of oil and gas methane regulations, such as informing their proposal to allow advanced screening for leak detection. This federally funded data likely would enable companies to reduce their emissions and publish their own measurement data to demonstrate when they have lower methane intensity than their peers, which would help domestic and international consumers make informed decisions when they purchase natural gas. In summary, oil and gas methane emissions are a serious problem, but has achievable solutions. And the federal government can drive emission reductions by funding the development and implementation of advanced technologies to detect, quantify, and mitigate emissions. Thank you for your time.
Next up is Mr. Duren. Can we please make sure the camera is on?
Yes, thank you. Good morning, Chair Johnson, Ranking Member Lucas, and committee members. I'm Riley Duren, CEO of Carbon Mapper, a nonprofit organization with a mission to deliver precise and transparent global methane and CO2 emissions data at facility scale to help guide emission reductions. The urgency of cutting methane emissions can't be overstated. No observations indicate growth rates and atmospheric methane concentrations over the past 2 years that are unprecedented since systematic measurements began in 1983. But there are solutions at hand that can still reverse course and limit global warming. It starts with making invisible emissions from all sources visible and therefore actionable. My comments today are grounded in a methane research program that I helped establish over a decade ago at NASA's Jet Propulsion Laboratory. This research continues today at Carbon Mapper and through my joint appointment at the University of Arizona, and it's benefited from sustained support from NASA with contributions from NIST and the California Air Resources Board. Over the years, we've proved that when armed with data and insights on methane point sources, people can take action to stop these emissions. It was these research findings and the support of our philanthropic donors that motivated us to form a public-private partnership with JPL, Planet Labs, the state of California, and others to launch a global constellation of satellites starting next year to find, measure, and communicate emissions about methane and CO2 point sources. The oil and gas industry has the tools and technology today to cut methane emissions more quickly and cheaper than any other sector if they know where to focus. The benefits of doing so extend far beyond climate. Given expanding demand for U.S. natural gas exports, managing methane emissions in the U.S. from oil and gas supply chain is becoming increasingly important for national security and global competitiveness. Additionally, because methane is an ozone precursor and is often co-emitted with other toxic compounds, improving methane monitoring mitigation is important for local air quality, health, and environmental justice for millions of Americans who live in close proximity to oil and gas infrastructure. The U.S. oil and gas sector is characterized by millions of active and inactive production sites, pipelines, and other infrastructure distributed over vast and often inaccessible areas with significant variation in their age, operational status, productivity, and management practices employed by operators. This enterprise is a complex and entangled web of different jurisdictions and regulations, translating to significant variability by region, production segment, and equipment type in terms of the monitoring requirements and enforcement responsibilities. Many operators and regulators, unfortunately, today remain largely uninformed about actual methane leakage because current measurements are still too sparse, infrequent, and/or insensitive. And while some companies are undertaking prototyping programs, which is great, the resulting data is often proprietary or behind paywalls. Bottom line is most U.S. oil and gas infrastructure today is still not sufficiently monitored for methane emissions. In recent years, our research team and our partners have applied methane observations from surface sensor networks, aircraft, and satellites to quantify and track methane emissions from 5 U.S. onshore oil and gas basins, among other work that's summarized in my written testimony. We've seen concrete evidence that good data can translate directly to mitigation action. So for example, by sharing advanced methane data in California with operators, our research pilots have led to voluntary methane leak repairs at 44 facilities that translate to over 1 million metric tons of CO2 equivalent reductions that have been verified by follow-up overflights. Emerging examples in other states are showing that timely and precise data can directly enable real reductions. Congress has an opportunity to lead by marshaling U.S. science agency contributions to augment operational monitoring by companies with these recommendations. NASA and NOAA could commission annual surveys using satellite and airborne observations to quantify methane emissions from key U.S. onshore and offshore production basins to support the National Greenhouse Gas Inventory and evaluate the overall efficacy of oil and gas methane regulations. NIST can establish standards for methane emission detection and quantification, including independent evaluation of basin and facility level measurements to validate their accuracy. DOE and NASA could prioritize methane measurements in their technology development portfolios, including improved sensitivity, spatial temporal completeness, and solutions to variable illumination conditions and wind uncertainty, which remain significant challenges. Federal agencies in doing this can maximize the acquisition of data from non-federal sources, including private sector, academia, and non-governmental organizations. By providing scientifically robust interpretation and transparent public dissemination of data, federal science agencies are uniquely suited to leverage the expanding global ecosystem of methane observing systems. In closing, preventing methane leakage can prevent runaway warming now. There's an urgent need for U.S. science agencies to strengthen methane accounting and mitigation efforts by governments at all levels, companies, and broader civil society. And as I've mentioned, these investments can improve both U.S. standing and technical contributions internationally while supporting local air quality and equity needs of local communities across America. Thank you very much for the opportunity today, and I look forward to your questions.
Great. Thank you, Mr. Duren. And after that, we're going to hear from Dr. Anderson.
Good morning, and Chairwoman Johnson, Ranking Member Lucas, and other distinguished members of this committee. Thank you for the opportunity to discuss methane emissions research and development today alongside my fellow distinguished witnesses. To help lead a clean energy revolution that achieves a carbon pollution-free power sector by 2035 and puts the U.S. on an irreversible path to a net zero economy by 2050, we at NATL are accelerating technologies not only to decarbonize power generation and industrial sources, to remove carbon dioxide from the atmosphere and mitigate environmental impacts from fossil fuels, we're also working on the methane emissions technologies. Our essential technologies in the administration's plan to decarbonize the economy, one is the production of carbon-free hydrogen and ammonia, in addition to carbon capture and sequestration. Where hydrogen and ammonia production relies on the existing natural gas production and distribution assets, there's an opportunity to achieve 4 different goals. We can stabilize the climate by taking cost-effective steps to tackle near-term threat of methane, a very potent greenhouse gas that we've discussed that accounts for about half of the rise in global average temperatures since the pre-industrial era. We can keep communities free from contamination of their water and air supplies. We can advance American technology to address decarbonization, and we have an opportunity to create jobs. As outlined in the Office of Fossil Energy and Carbon Management Strategic Vision, NETL supports research to address mitigation and quantification of methane emissions from fossil energy supply chains, from resource production, processing, transportation, utilization, and storage. NETL is also developing accurate, cost-effective, efficient technology solutions and some best practices to help identify, measure, monitor, and eliminate methane emissions from these sources. There are unique challenges associated with methane emissions from the natural gas sector that include efficient and permanent plugging and abandonment of orphaned wells, resilient pipeline materials and aging equipment, and flaring of associated gas at the wellhead due to insufficient takeaway capacity through conversion to sustainable chemicals and solid carbon products. So our scientific research informs efforts to better understand methane emissions and to design more effective monitoring, quantification, and mitigation strategies through an integrated monitoring platform and accelerating technology solutions that are focused on real-time continuous monitoring. For example, since 2005, NETL has developed rapid airborne methods for locating undocumented orphaned wells through the development and field validation of advanced electromagnetic hardware and machine learning software that helps bridge the knowledge gap and quantify emissions to prioritize the management for our plugging efforts. In addition, for the last decade, NETL has served as the Office of Fossil Energy and Carbon Management's national expert in evaluating and communicating life cycle environmental information to stakeholders in the US and around the globe to understand the natural gas extraction, delivery, and electricity production landscape. Our laboratory also focuses on low-cost, low-maintenance pipeline sensor technologies that can monitor corrosion rates, gas leaks, and gas stream chemistries, and enable a more intelligent natural gas infrastructure. NETL is also developing methods for integrating sensors via wireless telemetry, testing procedures for embedded sensors in coated pipelines, and conducting field-based tests of pipeline monitoring systems that verify performance, as well as having advanced pipeline materials for corrosion protection systems and real-time sensor technology. These innovative technologies are tools for methane monitoring, detection, and quantification, as I've mentioned before, and they're essential because quantifying methane emissions is complex, as we've discussed. It requires robust, resilient sensing platforms that operate ground-based, aerial-based, satellite-based solutions focused on highly granular continuous data collection that can enable rapid response for methane mitigation operations. These technologies must also be supported by advanced communication protocols and transformational data analytics to observe methane concentrations associated with natural gas systems and provide predictive capabilities to repair and replace potential methane emission sources before they present an environmental concern. Through R&D and partnerships with industries, universities, other national laboratories, and of course, federal investments, including the Department of Energy's ARPA-E program focused on reducing methane emissions, we will continue to drive the commercialization of products and processes that achieve U.S. and international decarbonization goals while supporting job creation and global competitiveness as the world's energy transition proceeds. So our quantification and mitigation portfolio has 43 active projects, both internal at NETL and with our extramural partners across methane detection, field trials, equipment technologies, pipeline coatings, machine learning, and others. So thank you very much for the opportunity to discuss some of these cutting-edge innovations to methane emissions, which have applications within and beyond the energy sector.
Excellent, great testimony so far. And next, we're going to hear from Dr. Rieker.
All right, thank you very much, Chairwoman Johnson, Ranking Member Lucas, and distinguished members of the committee. Thank you for inviting me here to testify today. You can't improve what you don't measure, and that's been the topic of this discussion here and all of my work over the past decade. You heard about the work of the other witnesses interpreting data from satellites, airplanes, and field crews to generate large-scale emissions data sets for decision and policy making. The additional critical component that I hope to bring to the conversation is that the action of emissions mitigation happens at the local level. The oil and gas operators need to know in real time the location, the size of leaks, so that they can fix the problem. And that's what LongPath brings to the challenge. We've been called the 5G of methane, a network of continuous monitoring that feeds back instantaneous emissions data to oil and gas companies 24/7 and alerts them as leaks are happening. We use Nobel Prize-winning frequency comb lasers that emit hundreds of thousands of colors of light. We quantify the level of methane and other greenhouse gases by detecting how much of each color of that infrared light is absorbed while it's traveling through the atmosphere. The systems are tower mounted, and each tower covers an area of about 20 square miles and provides specific quantitative emissions rate data on a well-by-well basis for customers within the purview of these towers. It's about 10 to 1,000 times more sensitive than aerial and satellite approaches and quantifies emissions from specific facilities many times each day and each night. And critically, it sheds light on the intermittent emissions that were mentioned earlier, one of the most common forms of emissions in the field. There's nothing like this in the world, and it's a true product of American ingenuity and an example of government support for technology development in action, as the prior witness just mentioned. I started working with frequency combs that underpin this LongPath technology in 2012 at NIST, the National Institute of Standards and Technology, where a lot of the early government-funded work on frequency combs happened. I moved as a professor to the University of Colorado and was funded in 2014 by ARPA-E, the Department of Energy's Advanced Research Projects Agency that I know many of you on this committee have played a heavy role in creating and maintaining, and thank you for that. Our team transitioned this technology finally to a proven commercial product in 2020, and we now have systems covering almost 300,000 acres with 17 oil and gas companies as customers. We're on track this year to reach almost 650,000 acres with a boost from the ARPA-E scale-up program. What's important from this story, aside from the example it gives of the R&D machine in the United States in action, is that this, along with many other technologies that are coming into this space, have just reached the market in the last few years. The relative newness of these technologies means that there's a struggle on how they should be incorporated into policymaking, as well as a general lack of knowledge of their existence and capabilities within industry. I therefore hope that there are three things that you'll take away from my testimony today. The first is that powerful new technologies exist that can help us not just understand emissions, but give companies the kind of immediate feedback that they need to control them. The second is I urge you to consider technology evolution in the policy making that this and other bodies are considering today. EPA policies that stipulate a particular technology or a particular method, or SEC rules that punt on measurement altogether and are based on counts of equipment and calculated emissions will set us back years in making American oil and gas the crown jewel of low emissions production worldwide. LongPath has provided to the EPA a detailed work practice and framework for the inclusion of continuous quantitative monitoring as an alternative means of compliance, performance-based compliance. And I hope this component will enter the upcoming rule. And finally, third, I urge you to think about the role that government might play in methane emissions abatement as a public good and a public infrastructure, just like a road or a bridge or internet connectivity. Could we competitively bid an infrastructure project to build a multi-technology monitoring network across our production basins? LongPath, in collaboration with other methane data providers, can cover the methane. That's one of our largest oil and gas basins in the United States, with the infrastructure for 24/7 monitoring for less than the cost of the last James Bond movie. So I think we have to sit and think what our priorities really are. Thank you for the opportunity, and I look forward to further questions.
Well, excellent. And before we start our questions, I have a letter here from GHG SAT to be entered into the hearing record. And so without objection, so ordered. At this point, we're going to begin our first round of questions, and the chair is going to recognize herself for 5 minutes. Reducing methane emissions from the oil and gas sector is one of the fastest, most cost-effective ways we could reduce global warming that changes our climate. And I'm committed to fighting climate change because it is fueling more severe weather events, extreme flooding, and power outages in the communities I represent in Southeast Michigan. So Dr. Lyon and Mr. Duren, both of you in your testimony highlighted the role of super emitting methane leaks, or as you put it, Dr. Lyon, the mere 5 to 10% of methane sources that are responsible for more than half of all methane emissions from the oil and gas sector because of their massive size. The science is telling us that super emitters are central to the problem, but the committee's staff investigation found that oil and gas companies are failing to prioritize super emitters in their methane mitigation programs. The companies are not defining them, tracking them, or targeting operational changes to try to anticipate them and reduce their frequency. So, Dr. Lyon, is the scientific evidence regarding the role of super emitting leaks compelling enough that oil and gas companies should be making them a priority?
Yes, I think there is enough scientific evidence to show that super emitters are a major problem and should be one of the priorities of oil and gas companies. So really trying to detect these super emitters and then do root cause analysis to figure out what changes do need to be done to prevent the recurrence. But there also are a lot of emissions from other sources, including low production wells. So I think it really takes a comprehensive approach of both addressing the super emitters and the more lower emission source types.
And Mr. Duren, what are the implications of failing to address super emitting leaks for the oil and gas sector's ability to reduce methane emissions widely and quickly?
Well, I think the big argument is opportunity loss. I think it's been pointed out by a number of speakers and some of the committee members that, super emitters represent low-hanging fruit. They're the fastest way, and in many cases, the most cost-effective way to reduce a lot of methane really quickly. We have a new paper out, or coming out soon, looking at multiple U.S. oil and gas basins that find that between 20 and 60% of the regional emissions are basically dominated by a small number, usually maybe 100 or so, super emitters. And it's not oil and gas, but it's a lot of it. And that, to me, is just, it makes common sense to go after the big ones first. This is like triage. If you think about it, if you've got heart trouble, you need to treat the heart attack first and then worry about your long-term, need to get on statins and so forth. So I think there's a need to address all of these sources. And as Dr. Rieker also pointed out here, is this, there's no Swiss Army knife approach to this. We need a system of systems approach. And that means focusing measurements on the different classes of emitters, including super emitters, but also a lot of the smaller emitters. And it really does take a systems approach to get there. And fortunately, we have technologies in the science community and in the oil and gas industry that are becoming shovel ready. We need to scale up and operationalize them and put them to work across the U.S. so we can close these leaks.
Yeah, well, we are all about the systems approach here on the Science Committee, and understanding that any problem understanding any problem is the key to solving the problem. So quantifying methane emissions, measuring the size of methane leaks individually and collectively is vital to grasp the scale of the problem and improve the mitigation techniques to fix it. And that's why the findings of the committee staff investigation are so obviously alarming and obviously disappointing regarding the unwillingness of oil and gas companies to use quantification data to improve their leak detection and repair programs. So, Dr. Lyon, how important is it for oil and gas companies to incorporate quantification data into their methane mitigation efforts in order to act more efficiently and effectively?
Yeah, so I think for particularly the leak detection and repair programs, it's important to have kind of a pseudo quantification. So I don't think companies need to know exactly how much emissions are from various sources, but have the rough order of magnitude so they can prioritize the repairs. I think where quantification is very valuable is more in the reporting. So having a method so that companies can use measurements to accurately report their emissions and give confidence to consumers and other stakeholders that the reported gas performance is accurate.
Great. Well, thank you. With that, I'm going to yield back and recognize Mr. Lucas for 5 minutes of questions.
Thank you, Madam Chair. Dr. Rieker, as I mentioned in my opening statement, the ARPA-E program at DOE has received bipartisan support from this committee for many years. In fact, Chairwoman Johnson and I led legislation that reauthorized and increased funding for ARPA-E last Congress. It was signed into law as part of the Energy Act, and we're looking forward to the program's success over the next couple of years as a result of that. I was pleased to see that LongPath is a 2-time ARPA-E award recipient, but I remain concerned that even technologies like yours that receive federal funding still run into federal regulations that can ultimately kill its commercialization. So my question is, how do you and other ARPA-E projects with long-term uses like the Methane Emissions Technology Evaluation Center interact with the regulatory agencies like the EPA during the ARPA-E funding process?
That's an excellent question, and thanks again for your support to ARPA-E. So I think it's incredibly important that we understand sort of the cycle of how these problems come to light and then how we solve them. So there's early work that's been done by NOAA, by EDF, and others that kind of identifies the problem. That's when the folks at ARPA-E and DOE and NETL started to come in with programs that would support technologies that could solve this problem in a reasonable way. I think there's a right time to kind of bring in the regulatory aspect of this. And I think that right time is as we're starting to understand what technologies are going to be able to solve this problem. And so what we've done as part of the, our work with ARPA-E is try to engage with EPA as much as we possibly can, hold several meetings to bring them up to speed on what technologies are coming along. But most importantly, I think it's been up to us to kind of develop work practices that we can offer to the EPA for inclusion in rulemaking and suggestions for that, so that these technologies don't get overlooked. It's a difficult problem because these technologies are being developed so quickly and tested so quickly to be able to capture everything into these rulemakings as they happen. So I think often, lots and lots of communication, that's the key.
Continuing to discuss this particular genre, generally speaking, do you think current EPA rules and regulations are slowing down innovation?
I think that the current rules, and there was mention, I think, in your testimony about AMEL, which is the alternative means to allow technologies like this to come in, those are onerous for technologies like ours. And part of that is that it has to do with the fact that we certify, an emissions technology on a particular facility. There are tens of thousands of facilities across all of these oil and gas basins. And so I think it's very important that on-ramping of new technologies, alternative technologies, based on equivalency to current standards, which is what Colorado and other states have chosen to pursue. That's incredibly important to allowing our technologies to supplant some of these requirements. We've heard from operator after operator, I'm already going to have to do this. Why should I, pay more to do an alternative technology? So it's incredibly important.
The University of Oklahoma currently manages NASA's geostationary carbon cycle observation science operations and is responsible for science integrity of the mission. This will be the first U.S. satellite to precisely measure methane near Earth's surface and deliver much-needed data on the health of vegetation across the Americas and the release of naturally occurring greenhouse gases. Mr. Duren, since your organization focuses on global methane data, I'll start with you, and anybody else who wishes to comment can certainly chime in. If a system like GeoCarb proves accurate and useful for measuring methane at a highly granular level, do you think we should consider supporting a network of low Earth orbiting and geostationary located satellites globally, like we have for our space-based weather detection system already?
Yes, sir. I think that's a really good example of, and I think you kind of partially answered the question with the Weather Service analogy. And back to my point about a system of systems approach, the current and planned satellites like GeoCarb, like Carbon Mapper, like GHGSat, like satellites that are being fielded by the European Union and even the Chinese Space Agency have different capabilities to sense methane, and they are largely complementary, and they bring different things to the table. And so back to my point about there isn't a Swiss Army knife, we need a systems approach. And I, for one, am excited about seeing NASA launch GeoCarb because it'll provide high-frequency data that is difficult to get with other satellites.
Since these are worldwide issues, having the ability on a worldwide basis to assess the data just seems logical, much like the weather patterns. With that, I yield back, Madam Chair.
Great, and with that, we'll hear from Congressman Bonamici for 5 minutes of questioning.
Thank you, Madam Chair. Thank you, Chair Johnson and Ranking Member Lucas, and to our witnesses for this important hearing. The committee's staff's investigation into methane leaks revealed some alarming data about the true scale of methane emissions from the oil and gas sector. In particular, it's extremely concerning that internal company data shows that just a few massive methane leaks can account for most or all of the methane that a company reports to the EPA for its production operations in an entire year. This suggests that methane emissions from oil and gas sector are likely far greater than the official data indicates. So I'm going to ask each person on the panel, what would it mean if oil and gas companies better used quantification data to understand their aggregate methane emissions, and is additional innovation needed, or do we have adequate technology now? If you could do that in a sentence or two, Dr. Lyon, please start.
Yeah, so I think companies can use multiple measurements to quantify their emissions. I think the big question now is how they report that data. So currently the EPA greenhouse gas reporting program has very prescribed methods, mostly kind of bottom-up emission factors. So I think the key would be updating the greenhouse gas reporting programs to allow companies to use scientifically rigorous measurements to estimate their emissions.
Great. And do we have adequate technology now, or do we need more innovation, Dr. Lyon?
I think we have adequate measurement technology, but some of the data analysis, there are some outstanding questions, but I think they are very close to being solved.
Thank you. Mr. Duren, same question. What would it
The
mean?
big gaps we have now largely have to do with scale up and operationalization. It is about how much area is covered, how much of the equipment is sampled, and how frequently. We're making great progress in selected areas with pilot programs and prototyping, but we're only a small fraction of the way there. We need ways to help the industry and agencies scale up quickly. And so it really is an operationalization, I think largely operational scheme today. And then again, working on research to enable additional improvements down the road.
Thank you. Dr. Anderson?
Thank you. I agree with both previous witnesses. And what I would add to that is there are certainly many of the super emitters. Some of the numbers we've heard, 10% is half. We also have some numbers that indicate that 20% is 20% of the emitters result in 80% of the emissions. And certainly the identification of those lowest hanging fruits gives a tremendous opportunity with existing technologies for replacing equipment, either compressors and valves that those technologies are ready to replace many of the super emitters.
So you mentioned existing technologies. Do we need additional innovation, or do we have adequate technology now, Dr. Anderson?
Well, there's adequate technology to begin the pathway of the low-hanging fruit, but the advances in technologies, both in a mitigation, long-term mitigation and prevention, as well as in total quantification and covering the full landscape. So being able to cover larger swaths of the infrastructure with less technology, less investment is an upcoming technological advance we need.
Thank you. Dr. Rieker, same question. What would it mean, and do we need additional innovation?
Yep. So I just want to follow on to what everybody else was saying there, that the technology exists. It's the scaling that we're in the process of doing right now. One thing I wanted to add, though, is that I think it's smart to have certification and think about certification as a way to reduce confusion on quantification within the industry.
Thank you.
There's been a lot of technologies developed, and that confusion can exist if we don't have certification of these technologies.
Thank you. Dr. Lyon, in your testimony, you mentioned that systems and technologies needed to cut emissions in half by 2030 are widely available and inexpensive. So that should be great news. But in 2021, that was the second record-breaking year in a row for annual growth of methane emissions. So clearly, we're not where we need to be. So Dr. Lyon, I know you've worked with operators and you work through the EDF. So in your opinion, why are companies not seeking out and implementing the technologies you describe as widely available and inexpensive?
Yeah, I think some companies are starting to implement the technologies. It's more the whole system of how they use the methane detection technologies to assess issues. And they're finding that a lot of the issues are more things like operational or maintenance problems. So it may require things like them to redesign their site. So I think it is a learning process of both kind of integrating the methane emissions data with understanding their own operational system so they can really reduce their emissions and increase their operational efficiency.
Thank you. And Mr. Duren, I think you have a few seconds left. You made a similar comment in your testimony. Do you have anything you can add?
Just quickly, that the issue here is completeness. We need wider area coverage, more frequent sampling, and more sensitive measurements if we're going to see enough of the methane to have a big impact on mitigating it.
Thank you. Madam Chair, I yield back.
And with that, we're going to hear from Mr. Posey for 5 minutes of questioning.
Thank you, Chairwoman Stevens. Dr. Rieker, with 75% of Florida's electricity being generated by natural gas and our nationwide electric grid already facing unprecedented number of threats such as rolling blackouts, do you believe the proposed rules in their current form increase compliance burdens or operating costs for existing natural gas production sites?
I'm sorry, it broke up just at the end. Could you repeat the end of the question?
I said yes. In the current form, do you think that the proposed rules will increase operating costs for existing natural gas production sites?
I think for existing natural gas production sites, what we're showing with our data is that the cost to add this type of monitoring and repair is often paying for itself in terms of lost product. Gas prices are quite high right now, so that's especially the case. But I do think, getting these technologies out, we're finding that the cost burdens can be offset often by keeping things into the pipe.
Yeah, I mean, Floridians have already seen a 20% increase in their electric bills this year. Do you think this would exacerbate that?
I don't see this as exacerbating it more than sort of the world conditions that exist around natural gas and oil production. Certainly everything that we do to add a little bit to what's happening and what's being done on these oil and gas production sites could add cost.
With the need of making sure Floridians have access to affordable, reliable electricity, what would the proposed rules lead to higher electricity bills?
This is difficult for me as sort of the arbiter of data that's out there in terms of what's happening on leakage. And so that's one I might need to follow up on in terms of how I think that would come down to costs for consumers.
What recommendations do you have for the EPA to ensure that the costs for the natural gas industry in meeting regulatory requirements and in meeting incorporating the new methane emissions reduction and detention technology don't jeopardize the operations of existing sources?
Absolutely, that's a great question. And I think that's allowing these new technologies to have the proper on-ramp that, as I was saying before, that don't require, an operator to do exactly what's stipulated today and try to add new technology on top of that. Making that on-ramp for new technology will allow them to cut the costs of some of the older, more efficient ways of doing the detection.
I got you. Well, thank you very much, Madam Chair. I yield back.
Great, and with that, we're going to hear from Dr. McNerney for 5 minutes of questioning.
Well, I think the chair, I think the witnesses, you guys are great. I love your testimony. It's a very exciting field. I think the technology being discussed here represents a great potential to simultaneously eliminate economic loss while addressing harmful emissions. It's a win-win situation to capture methane, and we should become a national global leader in this issue. Dr. Anderson, how could analytic advanced approaches like artificial intelligence help improve data analysis and make information more usable to operators?
Thank you for that question. I'm really excited about the opportunities for machine learning, artificial intelligence, data analytics, because as we deploy more sensor technologies and with more varying types of sensors and gathering those data, integrating them together and creative predictive capabilities for even sensing and predicting when you might have leaks from pipelines, or being able to integrate multiple sensor technologies into predictive capabilities When we can embed that into the technologies that are being deployed to lower the integration barrier for operators, then you can start having an opportunity to make real-time decisions, that operators can make real-time decisions and even have automated systems that can close valves and adjust compressor conditions when potential leakages are occurring. So there's a real opportunity of combining at the cyber-physical interface data analytics and machine learning.
Well, yeah, that's exactly what I'm getting at, and the predictive capabilities, I think, is a real promise. What about using AI to help detect or identify the super emitters?
I think when we're, in particular, we have some opportunities for top-down and bottom-up measurement convergence. That's going to be able to, we can start to identify the gaps between the top-down assessments and the bottom-up assessments that can point to potentially unknown super emitters. And by analyzing large data sets over large swaths of land, including satellite-based and aerial-based imagery, then we can start identifying potentially unknown super emitters that might be in abandoned orphan wells. Most of the super emitters that are on infrastructure are pretty well known, but I think there's opportunity for large-scale data analytics from top down to bottom up.
Thank you. Dr. Rieker, hey, your technology looks pretty exciting, using the electromagnetic spectrum to identify emitters and where they are is really good. Could you discuss, or when you discuss deploying LongPath's technology with prospective oil and gas clients, do they appreciate the potential benefits of a more effective, more science-based approach to methane mitigation? Or are you getting pushback?
No, I think that right now, so many of the adoption of these so much of the adoption of these new technologies is voluntary, that we're seeing oil and gas customers bring this system onto their fields, like what they're seeing, tell their neighbor. Again, this is a tower-based approach that can cover multiple operators at once. And so I think they're starting to understand what the real-time feedback can do for their operations. So we've not seen a lot of pushback on that. As I mentioned earlier, I think having kind of third-party certification of the quantification that's capabilities that are associated with these technologies is really important, because I think it's sort of easy when you have many technologies out there, some that work better than others, to paint with a very broad brush. Well, this technology doesn't quantify well, maybe this one doesn't quantify well either, and that's just not true. Each technology is specific. So I think that we're seeing kind of open arms adoption of this technology. I think the real question, as was mentioned in some of the testimony earlier, is they're learning as fast as they can how to bring this technology, or how the data from this technology can be integrated into their operations in a very efficient manner. And that's what we're seeing through all these different trials right now, is how do we best use the data?
Well, thank you. Dr. Lyon, are there particular categories of observation technologies that need more investment or need to be scaled up rapidly in order to fill in the gaps to create a more comprehensive monitoring system?
Yes, I think it's really several technologies and how to integrate them. So I think any technology that can image the emissions is highly valuable, because it can help the operator really pinpoint where the emissions are coming from. So I think improving those imaging technologies, but also continuous monitors. So really improving continuous monitoring, and particularly the data analytics, so that the operators can really effectively and quickly find emission sources and then repair them.
Thank you. I yield back.
Great, and with that, we're going to hear from Dr. Baird for 5 minutes of questioning. If he's with us. All right. How about Mr. Feenstra?
Thank you, Chairman Johnson, Ranking Member Lucas, and thank you to all the experts on our panel for sharing the expertise and experience on this issue we're discussing today. I'm proud to say that my district is a leader in energy alternatives to oil and gas. Biofuels, like those produced in my district, emit little to no methane and can help reduce methane emissions in our nation's energy portfolio. Dr. Rieker, Let's talk about some of the problems with the EPA's current approach to methane monitoring. Right now, the only compliance methods are handheld cameras or handheld sensors. That means it requires someone to physically go site to site and conduct the monitoring, which by logic would mean that some kind of emissions from their car could be detected. In this technology, you develop more accurate, if not simply equally accurate, information. Is there other compliance methods that we could currently look at?
Yeah, in addition to our technology. So I think it's a great question. I think it's great to point that out. It's a very labor-intensive process as it's kind of currently implemented in terms of these handheld cameras. That's what our company and many of the others that have been described here are trying to reduce that human intensity and increase the frequency with which measurements are being made. So I think the bottom line is trying to, again, create those on-ramps for technologies like ours, not to just purely supplant the need for, optical gas imaging and crews to go around and do some of these sweeps, but rather to direct those technologies so that they spend more time looking at and actually identifying the leaks that they're going to be fixing right there on the spot, rather than spending a lot of time looking at facilities that aren't leaking. So I think it comes down to seeing how we can make these regulations more performance-based and again, leaving the door open for technologies that can increase the efficiency that these types of regulations are implemented.
Thank you. I appreciate those comments. They're very important. Dr. Anderson, a research group at Iowa State University in my district has discovered and tested a way to keep methane out of the atmosphere. The process uses an extremely thin layer of platinum as a catalyst and converts methane into chemicals like ethylene. They are typically used in plastics and other materials. In your testimony, you mentioned other methane conversion techniques that involve electricity and microwave reactors to convert methane into hydrogen or formic acid. How do you see these and other methane conversion techniques factoring into the future of methane reduction strategies?
Well, thank you for that, and I applaud the work at Iowa State, and we have a lot of work going on at the laboratory and across our portfolio in methane conversion. There are opportunities in scaling down those chemical conversion technologies to where they can be deployed in the field through modular processes, converting into liquid fuels or hydrogen or even ammonia, resulting in lower emissions at the wellhead in the field, and then transportation systems would result in lower emissions across the midstream infrastructure as well. So a portfolio of those technologies of methane conversion into solid carbon products, as well as low carbon or zero carbon energy carriers, will play a role in the portfolio, particularly as we move into more deployment of hydrogen technologies as well.
Thank you for that. Just so for application purposes, where do you see this going? I mean, do you see this 3 years out, 5 years out, on where we can actually use the research that is being done to actually have the application done in the field?
On some of the modular conversion technologies that are achieving some high maturity rates today, so in terms of deployment into the field, into stranded natural gas assets that exist in the Permian Basin and in North Dakota, just north of you in Iowa, there are some opportunities within the next decade to be able to deploy those. Many of them would be around the commercial viability, economic viability.
Well, I appreciate you saying that. In the next 10 years, that's why it's so important that we do the research. And it's so critical that our universities are doing this research, and we have to make sure we fund this research and get this done sooner than later. Thank you for your comments. I yield back.
Great, and now we'll hear from Mr. Caston for 5 minutes of questioning.
Thank you, Madam Chair. Thanks so much to all our witnesses. You know, I love the Science Committee because we get all this good, fascinating information on data. But I think sometimes we have to remind ourselves that we measure these things because ultimately we have to go through and figure out how to reduce them. And of course, that's beyond the jurisdiction of this committee. But, you know, if my neighbors were piping their sewage into my back lawn, I would have a small problem of not knowing how much sewage is coming. I would have a big problem with the pile of sewage. I mention that because we are at a moment where we have hit an all-time high for CO2 in the atmosphere at 421 parts per million. The IPCC report that just came out said that we have already overshot 1.5. We're at 2 degrees of warming. It only feels like 1.1 because of all the soot in the atmosphere, which is cooling. And what was very clear when we were in Glasgow was that the only tool we have is to get the methane down as quickly as possible as a short-term forcer of warming to offset what's going to happen when the soot drops out. I say that because if we look at this current moment, as some of my colleagues are, in saying we should celebrate our progress, we are falling victim to what that famous wildcatter George W. Bush said in condemning ourselves to the soft bigotry of low expectations. Mr. Anderson, I want to come to you. If we are going to get the methane down, we need to not only know how much of it there is, but understand where it is being released and the causality. With enough information to understand where is it being released at granular levels, temporally, at granular levels, geographically, accommodating for various weather impacts. And what I'd love to hear from you is if we are to get at that level of causality, what are the top research priorities to really develop that kind of robust methane monitoring? Quickly.
So, quickly, I think that you know, some of it we have a number of undocumented wells that are currently emitting that are off of the infrastructure with a more difficult time to control. We are at the time right now with the bipartisan infrastructure law and the funding in the Department of Interior for plugging or for abandoned wells that we need to very quickly ensure that we have the technologies to identify those non-known super emitters so that we can plug those wells in the coming years. And then also on the infrastructure, again, I think that there's a lot known already about where those are, and so ensuring that the opportunities are there to deploy the technology that would cut down on the super emitters on infrastructure already is absolutely necessary.
Okay, so if we were to build this out, and I know we've been back and forth about, you know, what are the actual numbers, which of course was the whole question of this report. Do we even trust what the numbers are? It strikes me that the data that we have is in a lot of different databases. We have satellite data, we have LDAR data, we have, you know, private companies have their own metering data that are doing mass and energy balances on their pipelines. Does that, and this is a question for any witness who wants to answer it, does that data exist in some kind of comprehensive database? And if not, would there be value in some kind of a federally organized consortium to get that data so that we could actually understand where we have gaps?
Yeah, I'd like to comment on that. We've had some discussions with federal agencies about this. You've put your finger on an important gap. The short answer to your question is no. There is no such database. Currently, there are two types of emissions data out there. There's what I call type 1, which is focused at the national inventory level or maybe the level of states, and that's aggregate level emission. A lot of that data is in the public domain. It's generated by federal science agencies like NOAA, NASA, and EPA. And there's more we could do to operationalize that, provide more routine tracking to see how things are working writ large. But what's really missing is the type 2 emissions data. That's what we've been mainly talking about in this hearing, and that is data at the scale of individual facilities that operators can use to drive leak repair. And that is largely today still very spotty. Where it does exist, a lot of it's still proprietary behind paywalls, and there definitely is room and need for some sort of national data clearinghouse for data that is quality controlled and reviewed and credible and can be disseminated and used by many actors to get our arms around these leaks and exposures.
So just to that point, with the time I have left, it strikes me that once an oil and gas company has custody of the gas in their pipeline, they have an economic interest in getting as much of it to a meter as possible. But upstream, you've got multiple players, different releases, and we're into the scenario of my neighbor dumping sewage in my yard. Do you think that there is a way to get that data without some kind of mandatory reporting requirements and penalties for noncompliance?
The short answer is yes. It's a complex answer, and it's probably worth a follow-up conversation with more members of the panel and others who aren't here today.
Well, I'll take you up on that date, and I yield back.
Okay.
Thank you.
And now we're going to hear for Mr. Babin for 5 minutes of questioning. Thank you.
Thank you, Madam Chair. Appreciate it. Want want to thank Chairwoman Johnson and Ranking Member Lucas, and thank all of our witnesses for being here today. Last month, the Biden administration provided sanctions relief to Venezuela to encourage additional oil production there. According to the International Energy Agency's methane tracker, Venezuela has the highest methane emissions intensity in the entire world. The methane emissions from a barrel of oil produced in Venezuela are almost 8 times higher than the average barrel of oil produced in the United States. So if President Biden is blocking domestic production due to climate concerns, I'm curious why those same climate concerns don't apply to foreign countries that are run by dictators. My question to all of the witnesses would be, would it not be advantageous from a climate perspective to focus on ramping up our own energy production here in the United States, which is far cleaner than Venezuela and, quite frankly, any other nation in the world that produces oil and gas? If I could hear that, please, briefly.
Yeah, I can answer that. Sure. I think there is an opportunity for the United States and U.S. oil and gas companies to use measurements in a transparent way to demonstrate when their methane emissions are lower than some of the international competitors. And I think really we can build trust in a bunch of the stakeholders, including consumers, for perhaps U.S. LNG exports. So I think it really is advantageous to the U.S. when we can use measurements to demonstrate to the public that our gas, when it does have lower methane emissions.
I would quickly add that the satellite evidence unfortunately indicates that the U.S. is actually one of the highest methane emitters on the planet. And that's a paper we published in the journal Science with colleagues from Europe a few months ago that show there are a few jurisdictions where there is quite large methane emissions. And I think this is an opportunity for the U.S. to get out in front and lead. If we can reduce our emissions and show it through transparent data, then the markets will win out, because given the realignment we're seeing and natural gas supply chains in Europe, there's increasing demand for U.S. natural gas, and it benefits the U.S. from a strategic perspective and U.S. private sector in the world if we can reduce our emissions and show it transparently and provide visibility into all those other jurisdictions so U.S. operators don't
Mr.
operate.
Duren, I would hope that you would send me and provide me with documentation that is true, that we are producing more methane, because every single statistic that I see, we have the cleanest production methods here in the United States. And I proudly represent the 36th District of Texas. Anybody else want to say anything there?
I think I'll just chime in and say that, as was mentioned earlier, the United States is light years ahead in developing the capabilities for measurement and for reducing emissions across these fields. And so to the extent that we can accelerate that work, we are going to be able to be the gold standard and the provable gold standard for emissions. And I don't think it's far away. I think it can be done quickly. So
yes, thank you.
I support that we need to push our own production.
Right, thank you very much. Okay, second question to all. Are you aware of any country that has methane monitoring capabilities equal to what our oil and gas industry has? Because according to Wood Mackenzie, offshore deepwater production carried out in areas such as the Gulf of Mexico has the lowest greenhouse gas emissions of all sources of oil in the entire world. In fact, a 2016 analysis published by the Obama administration's Bureau of Offshore Energy Management, BOEM, concluded that ending lease sales in the Gulf of Mexico would increase global emissions by saying, quote, U.S. greenhouse gas emissions would be higher if BOEM were to have no lease sales. Emissions from substitutions are higher due to exploration, development, production, and transportation of oil from international sources being more carbon intensive, unquote. Of course, ending offshore lease sales, which makes us less secure, raises energy prices and increases global emissions, is a centerpiece of President Biden's climate agenda. Does anyone on the panel disagree that given that demand is constant, one of the best ways to reduce life cycle greenhouse gas emissions is to displace Russian and Iranian energy by expanding U.S. offshore oil and gas production? And following up on that, is it possible to expand U.S. oil and gas production while also continuing to decrease U.S. methane emissions. So if you can tell me the answer to those questions, do you know any other country that has methane monitoring capabilities equal to our own industry? And answer the other questions that I'd asked in the time that I have allotted, please.
Yeah, I can answer briefly. Yeah, so I do not think any other countries meet the U.S.'s expertise in oil and gas and methane measurements. And I do think we can likely increase our production while lowering methane emissions, and that will allow us to better compete with other countries who export oil and gas and have not invested in methane mitigation.
Thank you. I think I'm out of time, so I yield back.
Great. And with that, we're going to hear from Dr. Foster for 5 minutes of questioning. Thank you.
Yeah, I think one of the key things here is that your Representative Bettman's comment that given that demand is constant, that can't be true if we're going to actually solve the climate problem, that we have to find ways to displace natural gas basically as soon as we can with hopefully hydrogen and others. But given that we have this problem, could anyone say something about the endpoint of the comparison with space-based and land-based or I don't know, drone-based approaches? What is the best worldwide solution to this? Or do we have to, for example, if it is land-based solution, then our best strategy is to develop this technology and then give it away for free or is heavily subsidized to the rest of the world to get them to adopt it. And what is the low-cost way to get adequate measuring so that we actually measure the sources that are economically plausible to fix? Does anyone?
I'll start. I think it's going to require a combination of methods. I don't think there's a best solution. I think it is the portfolio of methods that we need. We're seeing this emerge now with pilot projects. Our own research team has been using surface network satellites and aircraft for over a decade. And a lot of people in industry are doing this now. And I think the question is, how do you scale up? And I think the answer to your question, Congressman, is how do you export this internationally? It's a little bit of a mixed bag. Some jurisdictions would benefit a lot from U.S. satellite data. Others would benefit from the technologies like LongPath. And I think it's a great opportunity for the U.S. research and development enterprise to export U.S. know-how. And it's going to lift a lot of ships around the world.
Yeah, this is Greg Rieker. I would agree with that. LongPath is doing its first international partnerships down in Australia in the coming months. And as was mentioned earlier, the kind of expertise, not just with our company, but many companies in the U.S. that have cropped up around this, the ability to export is extremely high. We're just way ahead, and I think we're going to be able to get out there and get in front of this problem in other countries as well. I think the mixing of the data is really important. The satellite data can give you the global coverage in a much sooner than we can scale up ground-based technologies. Again, the nice thing about the ground-based technologies is the high frequency and the high resolution, going facility by facility and delivering the data immediately to the customer so that they can fix this. So I think what you're going to see is waves of adoption, and satellites getting first to global coverage and then ground-based networks building up behind that.
The ultimate economics of it, are you going to just put lots and lots of satellites up there to get a higher frequency of measurement? Is that just going to end up not being a winning strategy, or is that something that's a plausible endpoint? One of the things I think we all worry about is that there are certain jurisdictions that may not be enthusiastic about having their emissions measured for a variety of reasons. Are there, if anyone have had a look at the ultimate economics of, for example, a very extensive space-based system and how that would compare?
Well, I think sorry, didn't mean to interrupt.
Go ahead.
I was just going to say that your point is exactly why we need the global systems, because the global energy supply chain is interconnected. There's not a single supplier of natural gas. It benefits the U.S. To deploy remote sensing technology and ground-based sensors around the world so that we have overall excellent situational awareness everywhere. To your cost point, this is one of the reasons why many of us on this, I think on this panel and elsewhere, are recommending to EPA that they adopt a matrix approach when asking operators to choose technologies that they can select between different price points that provide different levels of performance. Some work better in some regions and jurisdictions than others for different questions, and providing that flexibility gives industry and regulators, the degrees of freedom they need to innovate. And so rather than picking a winner up front is to provide a flexible approach that allows the most cost-effective, highest mitigation potential.
Absolutely. And I would just add in, I think, the technological challenges for the different technologies are different. So if there are clouds overhead, snow on the ground, these can be issues for satellite-based monitoring as well as resolution and sensitivity. So there are trade-offs, some that can be overcome and some that cannot, that makes this technology stack so important.
And is there a rough estimate of the total emissions from natural sources of all kinds compared to what we're doing with natural gas? Is that, if we get a factor of 5 reduction in what men are doing, are we now dominated by natural sources? What's that ratio roughly?
It's about half and half, natural and anthropogenic, and of anthropogenic, about a third is fossil energy, including oil and gas.
Okay, and are there plausible strategies to deal with the natural fraction, or are those that remains an unsolved problem?
Not at the present time. Our best option is to reduce the things that are shovel ready, and that's oil and gas emissions.
Okay, understand, and my time's up and yield back.
That's great. And we're going to try Dr. Baird. Mr. Garcia. For 5 minutes of questioning.
Madam Chair, Ranking Member, this hearing, to the witnesses, thank you for your testimony. I got a few questions, but Mr. Duren, I just want to clarify or have you restate the assertion that you made relative to the United States being one of the, I guess, the biggest offender of emissions. Can you not restate it, just remind me what you said there. I want to make sure I'm understanding you correctly.
Yes, sir. I want to be clear. That was one research study with satellites that exist today that cannot see all of the emissions down at facility scale. So I'm not talking about all the emissions, but we did a study with colleagues in Europe that identified so-called ultra emitters. These are sources that are emitting 50 tons an hour and up, and they're very short-lived, but they happen all over the world. And they are clustered in certain parts of the world. They stand out like wildfires. You can see them in North America. You can see them in Europe. You can see them in Africa. And so we have maps that show where the hot spots are. We're seeing the tip of a methane iceberg from space today. We can't see all of it. But what we do see with those high emitters is they are responsible for about 10% of global oil and gas emissions. And for that highest set of emissions, we can see very clearly where they are from space with satellites.
Are you tracking Asia and China in these equations, India as well?
Yes, yes, sir.
Okay. And so I'm very curious. I'd love to, I echo Mr. Babin's sentiment. I'd love to see that data and understand those assertions a little bit better. Because I haven't heard much about China in this hearing so far. And we all know that they are, from an emissions perspective overall, emitting more into the atmosphere than any other nation is, to include the United States. So I understand what you're saying and the nuances of the satellites and the imagery, but we do need to always keep China in the scan pattern as we're looking at the root causes of climate change. In my district, I represent California's 25th congressional district, which is northern LA County. We had the worst natural gas leak, I think, in the history of the country, maybe the planet, at Aliso Canyon Field. Do any of you have resources either deployed there in the past or currently or looking to in the future to help characterize either past emissions or residual emissions or sort of future mitigation and sensing in order to trigger warnings of future leaks with the Aliso Canyon? I'm just curious as to what is actually out there right now and whether or not you guys are playing in this field and what data you've seen.
Yes, sir. I can take that. We were heavily involved with the Aliso Canyon response. We continue to conduct research overflights for the California Resources Board. I'm happy to say that we don't see massive emissions there anymore. I also just point out that industry is taking positive steps, and I want to acknowledge SoCal Gas. Just provided a comment on a press release we had this morning about the the 2.5 million metric tons of CO2 equivalent reduced through voluntary action. And SoCal Gas is, taking the lessons from these research studies, and they've been investing their own measurements. I encourage you to reach out to them and see what they're doing in Southern California. I think it's a good example of what other companies can do around California and the rest of the U.S. again to build up and operationalize that kind of monitoring.
Yeah, on the backside of the incident, I think that's very true. We're in good comms with them, and I do think everyone's trying to do the right thing. My sort of latent concern with this field is that they continue to use natural storage facilities. Effectively, the caverns are just naturally reoccurring caverns underground, and it's just a couple miles away from the San Andreas fault line. So this, while they've done the hardening and the reinforcements of the valves and the pipes that were corroded as as root cause for this initial leak, the fundamental design of the storage facility is still vulnerable to seismic activity, and that's something that I think your guys' assets will help. Last question. The ships, ports of Los Angeles, Long Beach, and Port of LA, we've got a bunch of ships because of supply chain challenges nationwide that are just sitting out there in the ocean. Some of these are oilers bringing oil to the United States from the Middle East. Has anyone characterized the impact to the environment and the atmosphere of these ships just sitting off the coast? Very dirty ships from ports of call from the Middle East and countries that were dependent on oil. What do we know in that regard?
That's an excellent point from an air quality perspective and criteria pollutants. Without knowing more about who's currently sitting out there, I wouldn't want to comment about methane emissions, but since you raised the question, I will raise the point that this is an important topic to pay attention to as the U.S. increases LNG, liquefied natural gas exports using ocean tankers. I think it's important to understand what the true methane footprint of that supply chain is across the ocean, which traditionally is very difficult to measure.
Yeah, I'm out of time. I'll reclaim. I think that'll pale in comparison to the footprint of CO2 emissions emitted by ships bringing oil to the United States and that we're dependent on. But Mr. Chairman, I'm out of time, or Madam Chair, I'm out of time. Yield back.
Hey, thank you. And with that, we're going to hear from Mr. Byer for 5 minutes of questions.
Madam Chairman, thank you very much. Madam Chair, earlier this year, I led a letter along with Representatives Lowenthal, DeGette, Peters, and Leger Fernandez to the Environmental Protection Agency commending Administrator Rieker proposing strong rules to reduce methane and other harmful air pollution from both new and existing oil and natural gas facilities across the country and offering comments on the rules. And I'd like to ask unanimous consent to enter that letter into the record.
So ordered.
Thank you. The letter recommended that the rules apply comprehensively to smaller leak-prone wells that comprise the majority of the nation's fleet of oil and gas wells. And it also urged a stop to the wasteful, including practice of routine flaring of associated gas from oil wells. Mr. Duren, scientific evidence supports the idea that a small number of super-emitting leaks are disproportionately responsible for methane emissions from oil and gas operations. This is just Pareto's law applied to methane emissions. How can the federal government encourage oil and gas companies to focus on these opportunities for rapid emissions reductions, the super-emitting leaks?
Yes, sir. I think we recommend, a number of us recommended that I think both research investments and improving sensors, but equally important is federal investments in using agencies like NASA, NOAA, and NIST to conduct measurements at the larger scales to give us an idea of, at the end of the day, are these regulations and industry practices having the intended effect? In other words, it's important to be looking down at individual wellheads and flares with the individual technologies, but we also need to zoom out and look at emissions at the scale of basins to say, ultimately, is this working? And I think that's a really good place for the federal science agencies to fit. They have a lot of capability to commission and do their own work and hopefully engage others. And I really encourage that kind of investment from this committee.
Thank you. Dr. Rieker, the EPA's greenhouse gas inventory calculates methane based on estimates of what we know about oil and gas equipment under normal operating conditions. This means that it's not a tool to effectively measure the contributions of methane leaks to total emission, but is being used as one. What can Congress do to incentivize the development and readiness of methane quantification technologies, such as LongPath, to become integrated into the federal regulatory system?
So I think I'll answer that question right off, which is, as I mentioned earlier, with the number of technologies that are coming onto the market, there can be confusion about the capabilities of those technologies. And I think that third-party certification that is independent, companies should not be self-certifying themselves, is critical to encouraging sort of the uptake and the ability for these technologies to come together. Commenting a bit on your last question, continuous monitoring is that critical piece to get after these often intermittent and very large super emitters. And so I think to the extent that the federal government and different policies can really push for higher frequency checks, that's the best way. If we're only seeing these things once every 6 months, there's a lot of emissions that happen during that period before we caught them. And so again, that's a big gaping hole, that sort of certification body that can help arbitrate amongst the technologies that are coming online very quickly. That will help stimulate these companies to use more and more of these technologies.
Just following up on that, Dr. Rieker, the economist Thorstein Veblen said that invention is the mother of necessity. Is the availability of new monitoring systems, these new technological developments, likely to push the industry to develop operational change?
Yes, and we're already seeing that, and it's fantastic. So just the same way that these companies are using, pressure sensing and temperature sensors and flares to make sure that they're turned on, they're starting to see continuous methane monitoring as almost a check engine light for these facilities. So if something goes wrong on the facility, there's a good chance that we're going to see emissions of some sort because of a disruption in that facility. And so that's how a lot of these companies are starting to use this data. They take the emissions data as a trigger to grab data off of all of the other sensors on their facilities. And coming back to the earlier comments on AI, to be able to identify a root cause more quickly. And we have many examples of this where we've seen it work.
Thank you. Mr. Duren, I only have a half a minute left, but LiDAR technology. Is there something we can do in Congress to really kickstart the quick incorporation of LiDAR for this?
If you mean, direct sensing, yes, there could be more work. That again, for certain applications, it's great, particularly for searching things at night, and may have co-benefits for high latitude methane as well. But it's not a panacea. It can't see everywhere.
Thank you very much, Madam Chair. I yield back.
Great. With that, we'll hear from Dr. Baird.
Thank you, Madam Chair. Appreciate the opportunity to be with you, and it's always interesting to hear from experts in the field. And my background is agriculture, so I'm going to take a little jaunt off in that direction. In the fight against climate change, many innovative techniques, and that's what we've been talking about here today, continue to help American farmers and ranchers reduce greenhouse gas emissions. One of those technologies that I'm familiar with is tremendous, and it has tremendous potential, and can be used to not only eliminate animal waste, but also convert leftover food that can be used to produce fuels, and that's the methane digesters. So, Dr. Rieker, would you please share your thoughts on the value of methane digesters?
So, I'm not going to argue. I think it's a highly valuable technology to the extent that we can use what otherwise would become waste streams to produce energy that's useful to us. I'm absolutely in support of that. No further comment. I think it's good technology.
Do any of the other witnesses have any thoughts on that issue? Methane digesters. A lot of our producers in West Central Indiana have been very successful at utilizing these.
I totally agree, sir, that digesters, if properly installed and maintained, can have a significant net reduction, and that can generate biogas, which generates revenues for farmers. I do know that we've done a lot of work in California and Colorado doing overflights, and we have found that in cases where the digesters work, they definitely bring methane down, but there are also cases when they're not properly maintained where they actually generate a lot of methane. So devil's in the details, and I think one simple recommendation I would make is if we're going to install digesters, we could put simple on-site methane monitors to make sure that they're not leaking, just like you have a gas detector in your house, and I think that would go a long way to proving confidence in that technology.
And those can be relatively effective.
Yes, sir.
monitor that? Yeah.
Yes, sir. These are fairly
comfortable.
contained
Yeah.
facilities. It's not a hard thing to monitor.
Well, the other issue we get into, and that's not for this discussion, but I did want to mention it. You know, I think farmers and ranchers struggle with trying to find the support and the funding to put in those digesters. I'm not asking for your response on that kind of thing, but I do want to make that comment. I think they struggle to get sufficient support to install those units properly. So make that. Mr. Anderson, you got any thoughts that you would like to share on the methane digesters?
Well, I completely agree. They're very useful. The devil's in the details. I think that exploring the other options, not just in agriculture, but in municipal waste and landfill gas, that we need some robust solutions. And it is, yes, farmers and ranchers, but also the operators of landfills to ensure that we're capturing methane from all of the anthropogenic sources.
Dr. Lyon.
No, I just concur with the other panelists. I think it is an important opportunity for reducing emissions.
Wow, we've got agreement here. I mean, to tell you, we got a place to start. So anyway, I really appreciate your answers, and I think agriculture plays a role in all of this. And Madam Chair, I yield back. It's my pleasure.
How about that? All right, and with that, we're going to hear from Ms. Ross for 5 minutes of questioning.
Thank you, Madam Chair, and thank you for holding this important hearing. And I have some prepared remarks, but given Dr. Baird's question and what's been going on in North Carolina, I want to echo his interest in ways of capturing other forms of methane. I represented a number of companies as a renewable energy lawyer before I got elected to Congress, and did some great work on poop to power, which in North Carolina we call renewable natural gas. And I also got one of the first landfills licensed, got a certificate of convenience and public necessity for them to be able to sell their captured methane as a source of energy. I agree the devil's in the details in the technology, but we have some very effective and good examples in North Carolina. And so Dr. Baird, if you want to have some folks from North Carolina come and talk about how it got done, I am more than happy to invite them to this committee or any other committee. But I think this, we've been talking here particularly about methane that comes from natural gas extraction. And so I'll ask a few questions that go on with that. And as we've heard from most of the members and from the witnesses, we obviously can't mitigate what we don't measure, and leak detection is an essential step toward reversing overall greenhouse gas emissions and achieving our climate goals. And so taking advantage of technological advances toward addressing super and ultra emitting leaks presents a significant opportunity toward rapid and significant emissions reduction. And I know a lot about this in North Carolina. Since we've shut down so many of our coal-fired plants, demand for natural gas in North Carolina has more than quadrupled in the past decade, as we know, as a more reliable source of energy as we transition to more intermittent forms of renewable energy. But I want to ensure that these existing technologies are as clean as possible, and make sure that we use this opportunity to see them as transitions, as providing that backup for when the sun doesn't shine and the wind doesn't blow. I want to ask a question of Dr. Lyon and Mr. Duren first. Both of your organizations are working to launch methane monitoring satellites so that we can get kind of a high-level perspective. Can you please explain how you see the unique role of satellites in helping mitigate oil and gas industry emissions, and how they fit in with our suite of other innovative LDAR technologies, and what satellite capabilities exist today?
Yeah, I can start. Yeah, so I think some of the advantages of satellites is first that they can observe emissions in a lot of places where we don't have permission to fly aircraft, like Russia. And their value is really particularly looking at more of the larger scale emissions, so emissions at the regional or area level, but there are advancements in satellites that are allowing them to see some of the largest point sources.
Okay. Mr. Duren?
Yeah, I would just add to it that these systems complement each other. So MethaneSat is uniquely suited to quantifying emissions at the scale of large regions with exquisite precision to give us really exciting situational awareness. I say exciting with quotes around it. Important situational awareness, not just in the US, but globally, what we were talking about earlier. And Carbon Mapper really is focusing down at very high resolution, 30-meter scale with high frequency, ideally daily to weekly sampling, over 90% of the world's methane emitting and CO2 emitting infrastructure. So we have that wide area coverage and relatively frequent sampling. And these and other satellites can complement each other. We call it tip and cue, where somebody sees a hot spot in one location and satellite B is tasked to follow up on it. So we really are, within the next year or two, are going to be in a new world of capability. And you combine this with the surface measurements like LongPath and others, and we can get there. I do want to point out real quickly that what you made two examples, EDF and Carbon Mapper, MethaneSat and Carbon Mapper. These are both philanthropically funded programs so far. There is no federal funding for these programs. And so while it's great that the federal agencies have robust research programs, the things we're talking about in this committee and all these recommendations are going to need resources. And it's important to realize that it is a zero-sum research program. And so if we're going to do these things that we're talking about, there will need to be resources for these agencies to advance them.
Well, that was a great final pitch, and Madam Chair, I yield back.
Great, and with that, we're going to hear from Mr. Carey for 5 minutes of questioning.
Madam Chair, I thank you for the opportunity to ask my questions. I want to make just a couple statements. First off, knowing the importance of natural gas in our economy, I think if any of us read any of the trade rags, you realize the price at the Henry Hub for natural gas is almost double what it was a year ago. We all see the price of gasoline at the gas pump, but when you look at what it's actually costing the consumers back home, we're seeing that go up. So we have to be mindful of that. We also see the price of natural gas as it relates to Europe, and the prices are much higher. So knowing that methane is significantly attributed with the natural gas market, I'm looking at one of the charts Mr. Duren, I think, provided that showed a tremendous amount of methane emissions from the Pennsylvania, Ohio area. I'm assuming, and this question I guess would be for you, Dr. Anderson, with NETL. I mean, have you guys done significantly mapping in abandoned oil and gas wells, and what type of methane emissions are actually coming from those facilities?
Yes, and considerable. To put it short, we are undertaking both aerial assays for identifying orphan and abandoned wells. Pennsylvania, because there are wells that are 150 years old in the region, there are significant emissions in the Pennsylvania and Ohio region because of that from old abandoned wells. Many of these wells are hard to find. They don't have the steel in the ground anymore. Sometimes they were pulled out during the Second World War. Sometimes the casings were pulled out even earlier. So they are often hard to find. So we have a significant effort in mapping. We even have about 1,200 miles of mapping that we'll be conducting this year, I believe.
And Dr. Anderson, I mean, to that point, I mean, aren't there a significant amount of private companies that are actually out there having to plug these wells currently just to do the operations, whether it be coal mining or any type of underground mining operations? And shouldn't those companies somehow work in conjunction with your organization to make sure that the number of wells that have been plugged actually relates to the reduction in methane, that they are actually helping?
Yes, and they certainly work with the state agencies. So in Pennsylvania or Ohio, the Department of Environmental Protection at the state level. And so that we work in conjunction with the state agencies as well to understand the plugging and abandoning programs that the companies have. That is to say, those are for wells that are not orphaned. We have a significant number of orphaned and abandoned wells, somewhere between 90,000 or 150,000 orphaned wells across the country.
Dr. Anderson, real quick on that point, but you, I can't remember what organization actually did the charts, but on average, how much methane actually comes from an abandoned well? Was that your organization or was that another?
We've done some of those assays. Some wells it's negligible, and some wells it's considerable. I mean, it varies wildly, and so across the 100,000 abandoned wells, it spans the whole scope.
I guess the reason I say that, it seems to me that if we have an ability to actually go out, plug these wells, and I believe the President's budget also talks about doing some of that, but if we have the ability to go out and do that now to reduce the methane, and do so that is not going to cost the consumer any monies, but it will also protect the environment. I think that should be the priority, again, as we see the price of the Henry Hub and knowing that natural gas prices are continuing to climb, that's going to hurt the consumer. So my thing would go for the low-hanging fruit, and let's plug these abandoned mines and work with the industries that are in those areas to get that done.
The only thing I would chime in, Congressman, is that
well, thank you for chiming in, since I didn't ask the question, but thank you.
Sorry, sir. I was just going to try to elaborate. I do think the argument for low-hanging fruit is that the small number of super emitters are really a fast way. They're easy to find. They're typically easy to fix. The abandoned wells are, I think, an entirely order of magnitude bigger challenge because there's so many of them. They're hard to find. They typically emit at lower rates, and it takes a different focus, and it takes significant resources to close it. And I think there is a federal program to go after and close abandoned wells. I think a gap that we're trying to point out is there's still relatively limited programs in place to go after the super emitters, and that's why some of us are pushing that.
Well, thank you. Dr. Anderson, I don't have much more time, but I would like to follow up with you in terms of the studies that you guys have done on the emissions of methane from those abandoned oil and gas wells.
You can provide any information you'd like in the QFR.
Thank you, Madam Chair. I yield back.
And with that, we'll hear from Mr. Lamb for 5 minutes of questioning.
Thank you, Madam Chair. Dr. Anderson, welcome back to the committee. It's great to see you again, and we're very thankful here in Western Pennsylvania for your continued service at NETL. I actually wanted to stay on the issue of the abandoned wells just for a second. My colleague, Congresswoman Bice, and I have introduced a bill to try to help your research efforts along those lines. So I was wondering if you could just address, we expanded the amount of money available for the monitoring and finding of these wells. We put some of that in the bipartisan infrastructure bill. Could you address what that increase in funding has allowed as far as NETL's surveillance efforts in Western Pennsylvania, and where you see that the needs of that program going when it comes to kind of continued surveillance, or what is addressed in my bill with Congresswoman Bice has to do also with the prioritization of those wells by super emitter status. So if you could just kind of maybe just give us a more current update as to where your efforts are on that particular issue and where you could be going if we gave you the resources.
Well, Congressman Lamb, good to see you again, and thank you as well for you and Congresswoman Bice's leadership on that. I think that what we are driving toward is doing additional surveys, more surveys with additional sensing technologies that can identify the orphan and abandoned wells. And so we're using not only advanced electromagnetic hardware, machine learning software integrating what is gathered in the field, but the ability to scan large areas quickly has proven to be very beneficial. And so the increased of funding and efforts in that space is enabling us to go beyond just finding the wells, but then doing risk characterization, mitigation optimization strategies, using various sensors, again, laser-based, optical-based, high-flow gas sampling and compositional analysis, and then dovetailing into the bipartisan infrastructure law, where there's within the Department of Interior that we're collaborating very heavily with the funding for the plugging of those wells. We are simultaneously characterizing where those are and prioritizing the heavier emitters for the Department of Interior. So we have an interagency effort going on between the two agencies.
If we're talking about like a 100-yard football field, how far down the field do you think we are on the issue of locating and prioritizing these emitting abandoned wells?
I would say, given the level of uncertainty of anywhere, the estimates being from 90 to 150,000 wells, I would say we're still at the 20 or 30, our own 20 or 30.
Yeah, yeah, no, that's what it seems like. So we're going to have to sustain these efforts over time. I agree. Can you talk about the technological difference between surveying and identifying abandoned wells versus surveying and identifying leaks from the actual natural gas infrastructure system, how the technologies are similar or different?
Well, I think that if you're looking for the emission itself, the technologies are really similar. And so if you use the same kind of assays where you're identifying the leaks from existing infrastructure and you find an abandoned well that's emitting, that's a great find. However, given the breadth and distribution of those potential abandoned wells, we can't survey the entire landscape until we can narrow down where we think those wells are. And so as one example, in Western Pennsylvania, we know based on pictures from the late 1800s that in one particular location, we should have at least about 100 wells in some of that early oil field development. And to date, we've only found 20 or 30. And so there's still a long way to go.
Yeah, great. Well, thank you very much for your work, and we're going to continue trying to get you the tools you need to get this job done. Madam Chairwoman, I yield back.
Great, thank you so much. And with that, we'll hear from Mr. Gonzalez for 5 minutes.
Thank you, Madam Chair. Dr. Rieker, I'm going to start with you. As I'm sure you know, one of the drawbacks to satellite observations has been their considerable range of uncertainty and inability to apply to smaller emitting sources. While some progress has been made in this space in recent years, can you help explain how LongPath and similar technologies can identify leaks that today's satellites and drones simply cannot monitor?
Yep, 2 reasons. One, we're closer to the problem. So it's a challenge to measure small leaks from a very, very high altitude through clouds and through the rest of the atmosphere. So by bringing something like LongPath that's miles away from the emissions that it's measuring, or point sensor technologies right next to it, that's part of the problem. The other piece is just the ability to use active sources. And so our system uses a laser beam. We send a laser beam out rather than relying on the passive backscatter of light from the sun and other sources. And so it just is a much, much more sensitive way to do things if you're closer and you're able to use an active light source that goes out and sends the light that is absorbed by the methane and look for the change as it comes back.
Thank you. I want to talk about the laser-based sensor component with respect to cost. Currently, the gold standard is laser-based sensors, but can run anywhere from $10,000 to $100,000 per sensor. From a cost standpoint, do you have an estimate on the net cost to oil and gas companies that deploy your technology?
Yeah, so great question. So, again, with the networked approach that we're taking, we take that cost and we spread it over many, many facilities and, 13,000 acres per tower, like the one that's shown in my background here. And so the way that we approach this is almost like a telecommunications model, where you have a tower, it serves an area, and within that area, customers pay a certain monthly fee. And that fee can be very low, and probably don't want to put those fees on the record, but the numbers are low on a per facility basis, and they subscribe in for the data the same way you'd get your cellular data for a certain number per month.
Okay, so without getting into the specific, I understand the sensitivity around quoting specific numbers, but without getting into the specific numbers, from a unit economics standpoint, is it profitable for companies to deploy the technology, capture the methane, and then sell it back at a price that covers the cost? Like, is this net profit, or is it still underwater?
Yes. So we're seeing, and again, especially at the high prices that we're seeing for gas right now, that the net capture is exceeding the cost to monitor.
Got it.
And I should also mention a lot of these laser technologies nowadays, ours included, are built off of telecommunications laser technology. The same thing that's carrying broadband through the pipes. So it's very robust, and actually the costs are coming down at a very, very rapid rate.
What needs to happen from a pricing standpoint on the underlying asset, the oil and gas, before it becomes unprofitable again. You mentioned high gas and oil and gas prices are helping. I hope those prices go down. As I think everybody does. So I guess I'm curious, how far do they have to fall before it stops being a good economic play?
Yeah, so that's, I think, coming down to, a few dollars per MCF is potentially where those types of crossover points occur. And so that, that's not a high price. That's the kind of prices that we would be aiming for. So again, I think that as we learn more and more, and many companies are piloting this technology, and I mentioned earlier, it's new, so everybody's learning as we get these technologies out there, we're going to see more and more adoption on economic terms.
Great. I have 40 seconds left, but I'm seeing that I'm quite possibly wearing the ugliest jacket in the history of this hearing. And it's disgusting to even look at on this camera in front of me. So with that, I will yield back.
I didn't even notice the jacket.
You're too kind.
But with that, we're going to hear from Ms. Wild for 5 minutes of questioning.
Thank you so much, Madam Chair, and to my colleague, Mr. Gonzalez. I certainly hope your wife didn't buy you that jacket, or at least if she did, she's not watching this. So I didn't think it was so bad. Anyway, greetings, everybody. Thanks, Madam Chair, for holding this hearing. I want to direct my question to Dr. Lyon. I think it's notable, sir, that most of the technologies we've been discussing today go above and beyond anything currently approved by EPA for regulatory use, which I think shows that despite the flaws in the industry's current approach to methane mitigation, there are real incentives for oil and gas operators to do more than simple regulatory compliance in addressing emissions. Could you speak to why that is? Why are companies investing in these leak detection and repair programs that exceed what is actually required by EPA?
Yeah, I think a lot of it is due to market pressure. So there has been increasing demand for low methane emissions natural gas, and I think the public and consumers are getting more savvy on demanding that the performance is based on data. So I think a lot, but not all companies are seeing that by really demonstrating they have low methane emissions, they'll be able to sell more product.
Okay, thanks. Dr. Rieker, do you have anything you want to add to that?
No, I agree entirely. And that's sort of a follow-on to our prior comments there, that the capital market pressures, the fact that we lost out on an LNG terminal because, the gas from the Permian was considered too dirty. And I think these are the types of pressures that are really pushing companies to try to get ahead of the curve. And I think to the extent that EPA and policy making can make sure that it doesn't disincentivize getting ahead of the curve, that's incredibly important.
So when companies come to you to, this is still with Dr. Rieker, to try out your product, do they mention that kind of thing?
Absolutely. Yep. Absolutely. That cost is not the primary concern. It's trying to do the right thing, and then I think as we move on, they'll start to see, as they start to test these technologies, that there are economic benefits as well.
Got it. Okay, so to all of you, to the entire panel, can innovative methane leak detection and repair technologies actually help oil and gas operators reduce leaks in a cost-effective manner? I see some nodding heads. Anybody?
I think it's unanimous, yes.
Okay, great. So if we can access better data that helps us to pinpoint the worst offending leaks, is there a universe in which the burden to the industry actually decreases while emissions mitigation efforts improve? Anybody care to comment on that?
Yeah, I can try. Yeah, I think as the technologies advance and companies are better able to quantify their performance, there will be kind of a continuous, they'll be driven for continuous improvement to really demonstrate that they're better than the peers. So I think due to the economics, there'll be lower costs for both the quantification and really the mitigation effort. So I think, yeah, this market pressure will drive improvements to cost.
So Dr. Lyon, do you believe that ESG concerns are moving the oil and gas sector in this direction already?
Yes, I think many of the companies are being moved. I think there are some companies who are kind of falling behind, but many of the leaders are very concerned with ESG issues.
And Dr. Rieker, when you discuss deploying LongPath's technology with prospective clients, do they appreciate the potential benefits of this more effective science-based approach to methane mitigation?
Absolutely. Yep. I think it takes some time, I think, for customers, and this is why we see so many customers in sort of pilot phase. You know, you're setting up a laser 3 miles away and telling me exactly where the leak is. You know, it sounds a little bit like science fiction. And so they want these kind of pilot tests to understand this. But more importantly, I mentioned this before, getting how they take that data and incorporate into their operations is also new to these companies. And so how do we, you know, develop work practices for field crews to use this data to go affect that change? That's what everybody is working so hard on right now. And so I think we're going to see in late 2022 into 2023 that kind of an explosion of these technologies coming out into the field as people nail down how to do this efficiently.
My follow-up question was going to be about what concerns they expressed, but I think you nicely covered that in your answer. So thank you very much. With that, Madam Chair, I yield back.
That's great. And with that, we're going to hear from Mr. Weber for 5 minutes of questioning.
Thank you, Madam Chair. In 2019, the Department of Energy published an analysis that found natural gas pipeline from Russia to Europe's electricity sector has 41% higher life cycle emissions than American LNG shipped to Europe from the Gulf of Mexico, which happens to be my district, interestingly enough. My district on that Gulf of Texas has multiple ports that are already exporting LNG, so we have the infrastructure ready to increase that output. Additionally, the International Energy Agency estimates that the methane intensity of oil and gas production in Russia is 30% higher than in the U.S. Emissions in Iran are 85% higher for each unit of energy produced, and Venezuela, believe it or not, is an astronomical 652% higher. So my question to all witnesses, do you agree or disagree with the calculation that increasing U.S. oil and natural gas exports to Europe can actually decrease greenhouse gas emissions in Europe?
The report you referenced in 2019 came out of NETL, out of our laboratory, so I absolutely would say yes.
Okay, good to hear.
Yeah, and I'll add there are regional differences within the United States, but I think there are definitely basins that are going to have oil and gas methane emissions that are lower than Russia and Venezuela and Iran.
Okay, next.
I would agree that if we keep on the path that we're on with these innovations, that the U.S. will have and can have the cleanest oil and gas footprint in the world. And you're right, sir, that there are a lot of jurisdictions around the planet that need to do better. And that's one way this technology can help them do better. If we make it all visible, then there will be market forces on those other jurisdictions to clean up their act as well.
Well, it's the government forces I'm concerned about, but let's go with the next witness.
Yep. Last thing I'll say there is we're seeing a lot of midstream and providers, LNG providers, that are starting to test technologies in order to be able to stamp shipments with specific kind of carbon footprint numbers, almost a credit score for that. That's going to be incredibly important, I think, on the national markets.
Who else are we missing? Is that everybody? Must be. Let me ask you this question. This is for Mr. Lyon and Duren. Methane monitoring satellites that compare and contrast. That's pretty fascinating. We can watch those countries that you're talking about. So those emissions, as that satellite is monitoring those emissions, I guess in real time, and we'll stick with Mr. Lyon to start with, do those emissions move, waft, or travel?
So the methane plumes do move with the wind direction, but the satellite approaches can account for that. So they're using the wind speed and direction as they're quantifying emissions.
So let's say we have emission A on today from Russia. The satellite's it happens at noon today. Is the satellite in place to watch that plume, as you call it, move across the world?
It depends on how the satellites are. I think Mr. Duren could probably speak in more detail, but yeah, some of the satellites can be tasked for long times. Others do have orbits that are kind of recurring.
How about that, Mr. Duren? What say you?
Yes, sir. This background in my Zoom is an indication is exactly what we're talking about. These are methane plumes in the Permian Basin from one day of overflights with a remote sensing instrument, which basically simulates what these satellites will be. And so when we get these satellites in orbit, we'll be able to track this level of detail on all the countries around the planet. It'll be really clear where these emissions are coming from and where the plumes are going.
So we know, when the initial source of release is, how long will a plume stay together and finally not dissipate? I'll stick with you.
Yes, sir. The one thing to know about methane and other greenhouse gases is they are well mixed. That means within hours to days, they are well mixed in the atmosphere and they become dilute and they just contribute to the global total. So to actually figure out where that plume ends up over the course of weeks and months, you need complex computer models because at some point it just becomes part of the background. So very quickly they mix, typically within hours to days.
So you have a pipeline, and I remember when they used to fly pipelines with Piper Cub airplanes, looking for an oil leak in the ground. Of course, now in real time with all the computers, the monitoring they have, they're so efficient. It's really, really good. So you have a pipeline or you have a source of emission. Do you communicate that back to that source, whether it's a pipeline company or whatever the company is?
That is an excellent question, sir, and it is complicated because there are, quite frankly, there are fragmented jurisdictions in the U.S. for who has responsibility over what. I have an example of where we found with one of our aircraft flights a leaking gathering line in the Denver-Julesburg Basin last summer, and it took us a few days to figure out who to call because it wasn't immediately obvious who was responsible. And that is something that could be a benefit of this research program, is to help to build a better database of where is everything located in the U.S. and who owns it, so you can expedite getting data that these aircraft and satellites see into the hands of the right people who can do something about it.
So in essence, and I don't mean this in a negative way, that could be an income stream, because if you're a company ABC, you want to know about your leak as quickly as possible. And so if they would subscribe to your service, for lack of a better term, then actually that would be a win-win for y'all and for them.
Yes, sir. In fact, that is a big theory of change beyond these rapid sensing technologies we're talking about, is if you can get information into the hands of an operator within a few days or within a few hours of a leak springing, they can get that leak down before anybody ever calls them and bothers them about it.
Yeah, well, nothing personal, but we want you to call them within 15 or 20 minutes.
That's a good stretch goal. We'll shoot for it.
Well, thank you for that. With that, I yield back.
Great, and with that, we'll hear from Ms. Fletcher for 5 minutes of questioning.
Well, thank you, Chairwoman, and thank you so much for holding this really important hearing on methane emissions. Thank you to our witnesses for taking the time to testify. Your testimony, both written and then here today in the hearing, has been really useful, and certainly it's clear from this discussion that methane leaks are a major issue that will require a collaborative approach to tackle. As we've discussed, methane accounts for about a third of global warming, and methane emissions have risen by about 25% in the last 20 years. And this trajectory is obviously off from the decrease that's needed, 2% annual decrease that's needed to meet the standards that are set as the objective of the Paris Agreement. And most methane leaks are from a few major industries. And I think it's important to note, as we talk about it, and part of the complexity is this isn't just an oil and gas issue. Methane emissions arise from the agriculture sector, from coal industry, from waste management. There are a lot of challenges here. And I know that this is hugely important to many of us in Congress to help address the issue in the oil and gas sector in particular. I worked with Congressman Armstrong and the Environmental Defense Fund to pass the RECRO Act as part of the bipartisan infrastructure package last November. And the Infrastructure Investment and Jobs Act has this provision included to plug abandoned oil and gas wells, investing $4.6 billion toward cleaning up these orphan wells, and that will greatly reduce methane emissions from these sources. As we've heard throughout the day, today in this hearing. These new and innovative technologies really are the key to detecting and repairing methane leaks as quickly as possible. And certainly I think there's a consensus that, this is something everyone wants to address. No one wants to see these leaks going forward. And so, we know that's important, but from the statistics we've seen from last year, there still appear to be a lot of hurdles that prevent us from being where we need and want to be in terms of methane emissions. One of the things I also worked on last year in the last Congress was implementing the Pipeline Safety Pilot Program, which was included in the PIPES Act of 2020. And the language there really allowed for a pilot program to explore new avenues for deploying inspection technology in an effort to get these technologies deployed quicker. And that seems to be a theme we're hearing over and over. Unfortunately, with something like that, when PHMSA went through the rulemaking process, it didn't really consult with stakeholders who would be using the program, applying for the program. And so I've heard from a lot of people in the industry that the rule as written hasn't really created a process that can actually that they can use to deploy and test these promising new technologies. And I think it's really essential that we take a collaborative approach here to solving the problem of methane emissions, that we work together to figure out from both our vantage point in terms of what can be done and also the people who will be doing it are all coming to the table to do it and make sure that these things happen as quickly as possible. So my question is really to everyone on the panel, how can we in Congress, as the policymakers and others in the federal government, work more closely with stakeholders, folks in the industry, to make sure that these technologies are deployed faster and more comprehensively? What are the major obstacles that you've observed in the deployment of these new technologies? I know we have a limited time left, so I would love to put that out there for whoever wants to take it first, and then maybe if everyone else could, you could also submit it in writing, because I'll probably go over the time we have left. Anyone want to take that first, Mr. Lyon?
Sure. Yeah, I think the EPA can play a role. So making sure that the new regulation does have a flexible and expedient process, so that these and technology neutral process that allows a lot of these advanced approaches to be used and in a way that it really looks forward to maybe some technologies that we can't even imagine now, and making sure that those would also be allowed. So I think, yeah, EPA definitely has a role to play in to make sure that these approaches can really lead to methane mitigation quickly.
Okay, and that was quick, so we still have 30 seconds. Anyone else want to weigh in? Mr. Anderson?
I was just going to concur with that. I think that there's a demand side pull. There are technologies are being developed through the portfolio. Let's make sure that the pathway to deployment is clear.
Yep, this is Greg Rieker. I would add to that as well. We have to just be very, very careful not to disincentivize the uptake of these technologies. Many of the quantitative technologies are letting oil and gas companies understand what their emissions truly are. If there is discrepancy between that and what sort of the subpart W requirements are about reporting, there needs to be some reconciliation there, and also some kind of allowing these operators to deal with that reconciliation without being hurt by it. And I think that's really important, because it can be a disincentive to using quantitative technology.
Okay, well, thank you for that. I have gone over my time, but I appreciate how quickly you all were able to respond. And if you have any additional comments, please submit them for the record. I would very much appreciate it. And Madam Chair, with that, I yield back.
Great, and with that, we'll hear from Ms. Bice for 5 minutes of questioning.
Thank you, Madam Chair. And I want to maybe reiterate, Representative Lamb earlier mentioned the bill that we worked on together, HR 4270, the Abandoned Well Remediation Research and Development Act, that would focus on methods and materials to better find, plug, and identify methane emissions on these abandoned wells. It has passed this committee. It has not been presented on the floor yet, so I would encourage our friends to consider putting that up for a vote soon. I want to maybe piggyback off of something that Representative Kasten said earlier. He mentioned that his neighbor was dumping sewage in his yard. And I think this analogy could be translated to energy production and emissions. Of the 5 countries with the largest methane emissions from their energy sectors, China, Russia, the US, Iran, and India, Only the United States is part of the Global Methane Pledge. The pledge was launched at COP26 to try to reduce methane emissions by 30% by 2030. Mr. Duren, would you agree that we need to also focus on global reductions using advanced U.S. research capabilities and technologies to reduce global methane emissions?
Yes, I agree. This is something. It's global climate change has global in front of it for a reason. It's a global commons problem, and as I mentioned earlier, methane mixes really quickly in the atmosphere, and so wherever it emits, it becomes everybody's problem. I think that one of the problems we confront in meeting the objectives of the Global Methane Pledge and other climate programs like the Paris Agreement is that in most parts of the world today, we are still operating with very little situational awareness, very real direct data on emissions. We're limited to bottom-up estimates based on economic information and activity data. And there's a huge gap between what's really happening and what we need to know to effectively manage it. When I say we, I mean humanity writ large, not just one country. So I think that is one place where the U.S. and again, the research agencies under the jurisdiction of this committee can really lead. It's U.S. science and technology that can shine a light on methane emissions and other greenhouse gas emissions globally at actionable scale so that people can take action everywhere.
But I want to highlight something that you just said, and that is there's a lot we don't know, correct? There's a lot we don't know about measurement, numbers, how much is being emitted. I mean, those are things that there's a lot of information out there that we still don't understand or know.
We know enough at the global scale, at the scale of individual regions, to know that the methane emissions and CO2 emissions, what they are. What I mean by we don't know is we need more granular information that can drive direct action at facility scale. Remember that you think globally, but you act locally. And that's the gap right now, is information at the scale of individual facilities so you can guide improvements in management practices and fix leaks.
Well, I would say that, the United States is really acting locally. We're trying to do, especially our oil and gas companies are trying to do the best job they can to limit methane emissions, but we're up against a global situation that is not being addressed by anyone else, or very little is being done by those other 4 countries to be able to reduce emissions. Specifically China, we see there actually methane increasing, and that's going to be something that has to be addressed. I want to move on. Dr. Anderson, the EPA's current methane rule assumes that low producing marginal well facilities have the same exact equipment and emissions as higher producing sites and therefore contribute similarly to national emissions. Under this assumption, the cost of compliance with the set leak detection and repair requirements would impact all producers, but in particular, it'll affect small oil and gas operators of the almost 760,000 marginal wells located throughout the U.S., many of which are in my home state of Oklahoma. So as of this moment, limited data and broad assumptions could put many independent and small producers out of business. Does the NETL's study published in April titled Quantification of Methane Emissions from Marginal or Small Producing Oil and Gas Wells contradict EPA's assumptions on marginal wells?
I think so. Our study has a level of granularity based on the R&D that we've conducted in partnership with many of the small producers, and so I think that it can be used to help inform the path forward for the small producers, marginal wells, and we are continuing that research program. With that particular program on quantification from marginal or small producing wells continues, and so we'll continue to publish that information and put it in the hands of you.
But you would agree that marginal well production it has a much smaller methane emission than large producing wells, correct?
For modern wells, yes. With modern technologies, I mean, given that they are producing less and the cost for abatement is disproportionate, as you had mentioned as well.
Great. My time has expired. Madam Chair, I yield back.
Thanks, and with that, we'll hear from Mr. Sherman for 5 minutes of questioning.
Thank you. If you just watch MSNBC and Fox, you come away with the idea that oil production, gas production must be way down in the United States because the politicians are talking about it. The fact is that energy production in this country was higher in the first Biden year than in the last Trump year, and will be the highest ever in recorded history next year in 2023. We environmentalists would like to move us toward a fossil fuel-free future. And it makes sense to try to take steps so that we burn less natural gas and oil in the United States. Perhaps, unfortunately, some of the environmental effort is focused on trying to get us to produce less in the United States, which, as some of the witnesses have pointed out, means you just produce more elsewhere where the environmental regulations surrounding the production are usually less stringent. And the total amount of methane emitted greater. Mike Garcia was questioning earlier, his district and mine kind of intersect at the site of the largest natural gas storage blowout, not leak, but blowout in American history. As it happens, the emission was in his district and all the people affected were in my district. And so I focused on natural gas storage safety regulations. Which jurisdiction in the world, any state, any country, has the strongest natural gas storage safety regulations? If we want to be tough, who do we pattern ourselves after? Does anyone know? I'll ask any of the witnesses. We don't have an answer. I'll point out that Congress is required that we have, for the first time, before this gas blowout in Aliso Canyon, we had no federal regulations. That we have federal regulations, but they're pretty much weak regulations patterned after the Petroleum Institute's recommendations. Do any of our witnesses, we're dealing with the production of oil and gas, the transportation of the gas, and the storage. Do any of our witnesses in a position to put in context how much methane is released from those three types of uses of natural gas?
I'll just comment on the results of our work. It varies quite a bit by jurisdiction, and also, Congressman, I can point you to a study we did with the California Council on Science and Technology a few years ago in response to the Aliso Canyon blowout, looking at security and safety and integrity of underground gas storage, and it may have some answers to your previous question. But my answer is it varies quite a bit by region. In some places, the downstream natural gas system it emits more, leaks more methane than upstream. It depends on whether you're in a state that produces a lot of oil and gas as opposed to use it. So it varies quite a bit, and I don't
when
have a number for you.
You mean the upstream is the oil and gas well, or oil or gas well, and downstream is the transportation, storage, and then ultimately further transportation to where it's actually burned.
Yes, sir. If you look at natural gas in the U.S., it varies quite a bit whether you're losing more of the gas in cities versus upstream and midstream production.
Is underground storage of natural gas in abandoned oil wells or salt mines a safe system? Do any of our witnesses have a response?
I can comment on that. LongPath has done more than a year of monitoring on a couple of different underground natural gas storage facilities. One in California, although not Aliso Canyon. It's like all oil and gas operations. If these are properly maintained, the emissions rates are good, and so that's something.
And I do want to comment about proper maintenance, because Aliso Canyon was a disaster. But finally, do you have a comment on subsurface safety shutoff valves as being necessary for underground storage?
I don't have specific comment on that. No.
My time has expired. Thank you.
That's great. Now we'll hear from Mr. Perlmutter for 5 minutes of questioning.
Thanks, Madam Chair. Dr. Rieker, good to see you. Go Buffs. Professor, quick question. We had an opportunity recently to meet with your company out at the National Institute for Standards and Technology.
Yeah.
Can you explain, just in layman's terms for me, a little bit about the Nobel Prize for laser technology that now sort of undergirds the company and the system that you've developed?
Absolutely. Yeah, this has been kind of the, if you will, sort of the perfect transition of that kind of technology up through to a commercial product. So, in 1999 here at University of Colorado, Jen Hall demonstrated a laser that would emit hundreds of thousands of colors of light. And actually what's interesting about these colors of light is they're perfectly spaced by the pulsing of the laser. And so actually what he was developing was an optical clock. And that's what NIST is of course famous for, and the timekeeping standard. What's interesting is that researchers, myself included, could see that we could use all of these lights, all these colors of light to measure the unique absorption fingerprint of the different greenhouse gases. That's why they're greenhouse gases, because they absorb that infrared light. And so this technology, that Nobel Prize winning technology from here in Colorado, has gone on for timekeeping, for time transfer, the eventual replacement of GPS satellites with a different kind of time standard that's more secure, different kinds of quantum technologies. It's proliferated in many different directions. It's been very, very critical for NIST and other institutions like that to have the freedom to develop that technology over a time span. It took a decade before we started to shift it towards these oil and gas operations. And then it took Department of Energy funding to really push it over that hill into what we're doing here. So what it comes down to is these unique tools that are brewing in all of our research institutions. That's the seed corn, if you will, for all these innovations we're going to see in the next decade, next 2 decades. Yeah.
So, and this is to the entire panel, but Dr. Rieker, I'll start with you. So in Colorado, we have some pretty strict methane rules that the Department of Health has promulgated. It seems like we're at a conjunction now where both sort of environmental issues, reducing greenhouse gases, is coupled now with profitability, potential profitability for these companies to not lose methane or different kinds of fuels or gases that they might sell. Have you seen an uptick in terms of the oil and gas companies in Colorado wanting to use yours or other types of services like this? Is that something you're seeing now?
Yeah, absolutely. One of the interesting things, though, is that, again, this is the importance of writing the regulations in sort of a flexible nature. So some of the early kind of approaches in Colorado were fairly prescriptive, and that can, the operators will say, well, I need to do this prescriptive approach. It's going to cost me a certain amount of money. To add on and test new technologies, that's going to cost me additional funds. And so I think that Colorado, with its alternative AIM process, which we have an application in for, where we can show equivalency to that standard and then be accepted to replace the kind of less efficient older ways of doing the meeting the certifications. Once we clear those hurdles, and with the support of the oil and gas companies that are supporting those applications, we'll be able to reduce their costs. So it's a bit of a double-edged sword. You need that push, but you also have to be careful that companies are incentivized to make that push.
Any of the other panelists, Mr. Duren?
Yeah, I would say we're definitely seeing cases all over the U.S. where some operators are, I think, pretty proactively acquiring and using different types of measurement technology, remote sensing and otherwise, with dramatic results in some cases. But it is, I still characterize it as very prototypey, if that's a word, and there's a long way to go to scale it up and operationalize it.
Sure.
Dr. Anderson, go ahead.
Yeah, just quickly, I would point to what is called the Our Nation's Energy Future One Coalition. There's about 50 member companies in the natural gas value chains, about 20% of all of our natural gas production. Those companies have committed to reducing their methane emissions, and so they're already reaching for these technologies. And it's a combination of ESG and their own bottom line.
Dr. Lyon, my time has expired, but you were shaking your head. Go ahead and answer, and then I'll yield back.
Yeah, no, just saying I agree with that. Yeah, I think the companies, some of them are starting to implement it, and I think there'll be wider scale adoption, particularly if the regulations can be harmonized to use a lot of these technologies.
Thanks. And I guess I'd just say, you know, there's a lot of activity in this space, and we need to make sure that whether it's NIST or the Department of Energy or the EPA or the states, that they're able to use a lot of this technology as it develops. So thank you all very much for your testimony today. Thanks, Madam Chair. I yield back.
Thanks. So before we bring this hearing to a close, I wanted to thank our witnesses one last time. Oh, Stansberry's here. All right. Well, we were closing. Is she here? I don't see her. I don't see her. We're closing. Before we bring the hearing to a close, I want to thank our witnesses for testifying before the committee today. The record will remain open for 2 weeks for additional statements from the members for any additional questions the committee may have of our incredible witnesses. The witnesses are now excused and the hearing is adjourned.